Welcome to the calm cosmos. From the moment Earth was born in fire, it has carried within it the seeds of destruction. Mountains rose, oceans formed, and life crawled from the seas, fragile, uncertain, defiant. But survival has never been guaranteed. Again and again, the world has balanced on the edge of extinction, pushed to its limits by forces too vast, too violent, too merciless to ignore. Sometimes the threat came from the heavens, an asteroid falling from the void, shattering the age of giants. Sometimes it rose from within the planet itself, volcanoes tearing open the crust, filling the air with poison, choking oceans and skies. Sometimes it was carried in silence, through the breath of animals and the touch of strangers, invisible plagues that swept across cities, leaving empires in ruins. And sometimes the threat came from us, from the bombs we built, the gases we burned, the systems we trusted but did not control. For the first time in history, humanity itself became the greatest danger to its own survival. This is the story of those near endings, of the moments when life itself almost stopped, of the fragility of existence and the resilience that allowed it to endure. From the great dying of the Permian to the terror of the Black Death, from the silence of pandemics to the roar of nuclear fire, from climate collapse to the mysteries of the cosmos. These are the chronicles of apocalypse, and yet they are also the chronicles of survival, because each time the world nearly ended, life found a way to continue. This is not just history, it is prophecy, because the forces that nearly ended the world before still exist. And the greatest question of all is not whether the world will face them again, but whether we will be ready when it does. 250 million years ago, long before dinosaurs, long before mammals, long before human history even began to stir, Earth was alive with forms both familiar and alien. The continents, instead of scattered islands as we know today, were locked together in one colossal landmass, Pangaea. Imagine a world where you could walk, in theory, from the northernmost reaches of modern-day Siberia down to South Africa, from Spain across to China, without ever crossing an ocean. It was a connected global supercontinent, ringed by the endless waters of the superocean called Panthalassa. But Pangaea was a harsh master. Its vast interior was dry and arid, far from the moderating influence of oceans. Deserts stretched across thousands of miles, lands where rain rarely fell, and only the hardiest plants and animals could survive. Yet along the coasts, rivers and wetlands, life thrived. Forests of tall conifers, ferns and seed ferns covered the fertile edges. Insects swarmed in diversity. Dragonflies with wingspans larger than a man's hand, beetles and primitive flies. Reptilian ancestors of mammals called synapsids dominated the land. Some were small and burrowing, others were the size of crocodiles with sharp teeth and sturdy legs. Amphibians, larger and more varied than today's frogs and salamanders, still roamed rivers and lakes. And in the oceans, trilobites, brachiopods, ammonoids and reef-building organisms created teeming underwater ecosystems. It was a thriving biosphere. But all of this abundance was perched on a knife's edge, though the creatures of the Permian world did not know it. Deep in the earth, forces beyond imagination were preparing to unleash destruction on a scale no living thing had ever faced. In what is now Siberia, cracks opened in the Earth's crust. From these wounds spewed molten rock, fountains of lava that did not stop for years or decades but for hundreds of thousands of years. The eruptions were not the kind we imagine when we think of volcanoes today. They were not single, violent explosions. They were flood basalt eruptions, enormous outpourings of lava that blanketed the land in sheets miles thick, spreading across millions of square kilometers. This region is now known as the Siberian Traps, one of the largest volcanic features in the world. At the time, however, it was nothing less than an apocalyptic wound in the planet's surface. Lava flowed freely, swallowing forests, rivers, and entire landscapes. Ash clouds billowed into the skies, dimming the sun, spreading across continents. For those who lived through the opening years of the eruptions, the world must have seemed cursed. But it was not the lava itself that doomed life. It was what the eruptions poured into the atmosphere. Gigantic amounts of carbon dioxide surged upward, along with sulfur dioxide and other toxic gases. These gases worked in tandem to destabilize Earth's climate. Sulfur dioxide triggered acid rain, burning plants and leaching nutrients from soils. Rivers turned corrosive, stripping away life. At the same time, carbon dioxide built up, trapping heat. The planet first cooled under volcanic ash, then swung rapidly into hothouse conditions as greenhouse gases accumulated. This 1-2 punch shocked ecosystems, killing sensitive organisms unable to adapt to such extremes. As if that weren't enough, the eruptions also cooked vast underground deposits of coal, petroleum, and methane hydrates. These released additional greenhouse gases, creating a feedback loop of heating. The oceans absorbed much of this carbon, turning more acidic. Corals, shellfish, and plankton, the foundation of marine food webs, dissolved and died. Perhaps the most devastating effect of all came from the oceans. As the planet warmed, oxygen in seawater began to disappear. Warm water holds less oxygen, and circulation patterns that normally replenish the seas broke down. Gigantic dead zones spread, where nothing larger than bacteria could survive. At the same time, evidence suggests that methane-producing microbes exploded in number, releasing further greenhouse gases and making oceans toxic with hydrogen sulfide. Imagine entire seas turning into suffocating poisonous basins. Fish floated to the surface, gasping before dying en masse. Reef systems collapsed. Trilobites, which had survived multiple extinction events before, finally disappeared forever. In shallow seas, the water turned cloudy with microbial mats, covering once vibrant seafloors with carpets of slime. For millions of years, these microbial ecosystems would dominate, a world reduced to the simplest of life forms. On land, forests fell silent. Acid rain stripped leaves from trees, while drought and climate extremes stressed plants to the breaking point. Whole ecosystems that had taken millions of years to stabilize unraveled. Large herbivores starved, followed swiftly by predators. Synapsids like the once dominant Dimetrodon and Gorgonopsians dwindled, many leaving no descendants. Amphibians shrank in diversity, unable to cope with poisoned waters and unstable climates. Fossil records show fern spikes in the aftermath, layers where ferns briefly flourished after forests collapsed, only to vanish again as conditions worsened. It was a patchwork recovery attempt by nature, constantly interrupted by renewed catastrophe. The catastrophe did not happen overnight. It unfolded over hundreds of thousands of years in multiple pulses. Life would begin to recover slightly, only to be hammered again by renewed volcanic activity or climate shocks. This relentless cycle eventually broke the resilience of ecosystems. By the end of it, over 90% of marine species and around 70% of land species were extinct. Coral reefs vanished completely. Iconic groups like trilobites, which had survived since the Cambrian explosion, were gone forever. The Earth had come perilously close to becoming a barren rock, and yet life endured. Certain small reptiles, insects, burrowing creatures, and hardy plants clung to existence. In the seas, a few fish and mollusks persisted in isolated refuges. These survivors would become the ancestors of all that followed. Over millions of years, life would diversify again, giving rise to new lineages. Among them eventually were the ancestors of the dinosaurs, and much later, the ancestors of us. The Permian-Triassic extinction, the Great Dying, stands as the darkest chapter in Earth's biological history. It is a reminder that stability is temporary, that Earth's surface is fragile, and that survival itself can hang by the thinnest of threads. When the Permian extinction finally loosened its grip, the Earth that remained was a ghost of its former self. Imagine standing on a coastline where, once, vibrant reefs and swarms of fish filled the waters. Now the sea is murky and foul, a lifeless soup of microbes releasing poisonous gases. The air is heavy, the forests are gone, and silence echoes where insects once buzzed and predators once roared. This was a world stripped bare, a planet hollowed out by death. For millions of years, recovery seemed impossible. With ecosystems erased, the delicate chains of life had collapsed. Predator and prey relationships were broken, plant-animal balances were lost, and entire food webs no longer existed. Where once coral reefs stabilized marine ecosystems, now there were only barren seafloors coated in mats of algae and bacteria. On land, vast stretches of desert replaced lush forests. The Earth was alive, yes, but only just. In the oceans, the most complex ecosystems had vanished. Corals, brachiopods, and trilobites were gone, leaving space for the simplest organisms to dominate. Microbial mats and bacterial colonies spread across seafloors, thriving in conditions where larger animals could not. This microbial world resembled the ancient Precambrian Earth, as if the clock of evolution had been turned back by hundreds of millions of years. On land, plant life barely clung to survival. Fossil evidence shows repeated bursts of fern growth, fern spikes, that briefly covered landscapes after forests collapsed. Ferns, with their hardy spores and resilience, were nature's emergency response. But even they could not sustain dominance for long. Drought, acid rain, and soil erosion repeatedly scoured the land, preventing stable ecosystems from forming. Animal life was equally fragile. The great synapsid predators of the Permian were gone. Amphibians dwindled. Insects, once diverse, faced massive collapses. What remained were small, opportunistic survivors, creatures able to burrow underground, tolerate poor conditions, and live off meagre resources. The mighty had perished, leaving the stage to the overlooked. Recovery was painfully slow. Scientists estimate that it took at least 5 million years for ecosystems to begin stabilizing, and perhaps 10 million years or more for biodiversity to truly rebound. For comparison, after the asteroid wiped out the dinosaurs, Earth's ecosystems recovered within 2 to 3 million years. The Great Dying was so severe that life struggled for an entire geological era before regaining its footing. During this time, life existed in fits and starts. New species emerged, only to vanish again in repeated aftershocks of instability. Volcanic activity and climate shifts continued intermittently, punishing the fragile biosphere. It was as though the planet could not decide whether it wanted to recover or collapse entirely. And yet, even in this wasteland, evolution never stopped. Among the survivors were small reptilian creatures called archosaurs, a group that would later give rise to crocodiles, pterosaurs, and ultimately dinosaurs. Another group of survivors were the therapsids, mammal-like reptiles whose descendants would one day evolve into true mammals, including us. In the oceans, early ancestors of modern fish and mollusks endured, hiding in isolated refuges where oxygen was still available. Over time, they began to diversify again, slowly rebuilding marine food webs, coral-like. Organisms eventually returned, though it would be millions of years before reefs regained their former glory. These survivors were not the most powerful or dominant of the Permian, they were the adaptable, the resilient, the unremarkable. Their ability to endure harsh conditions gave them the chance to inherit the Earth. Evolution favours not only strength but survival, and in the ashes of extinction, the survivors write the next chapter. When biodiversity finally rebounded in the Triassic period, it was not the same as before. Entire groups of organisms were gone forever. Trilobites, icons of the Paleozoic, would never return. The great coal-forming forests of earlier eras did not recover in the same way. The very composition of ecosystems was different. Instead, new players rose. Reptiles diversified rapidly, filling ecological niches left empty. Some became swift predators, others massive herbivores. In the seas, new kinds of fish and marine reptiles dominated. The stage was set for the rise of the dinosaurs, who would soon inherit the planet and rule for over 150 million years. In this sense, the Great Dying was both an ending and a beginning. It closed the Paleozoic era, which had lasted for hundreds of millions of years, and ushered in the Mesozoic, the age of reptiles. To modern scientists, the Great Dying offers sobering lessons. Its cause, a cascade of volcanic activity, greenhouse gases, acid rain, and ocean anoxia, bears striking parallels to today's climate crisis. Though the scales differ, the warnings are clear. When carbon levels soar, oceans acidify, and ecosystems collapse, life faces the risk of mass extinction. Unlike the creatures of the Permian, humanity can foresee its impact. The Great Dying shows us that Earth's resilience has limits, and that once those limits are crossed, recovery can take millions of years, far longer than the lifespan of any civilization. The Permian extinction reminds us that life is fragile, that survival is never guaranteed, and that the stability we take for granted is temporary. But it also teaches resilience. Even after the most catastrophic die-off in Earth's history, life endured. From the ashes rose new lineages, new worlds, new possibilities. Without the Great Dying, there would have been no dinosaurs, and without them perhaps no mammals, no humans, no us. the Earth nearly ended. But it didn't. And in that narrow escape lies the reason we exist today. 66 million years ago, Earth was a paradise, vibrant, diverse, and alive in ways that would be almost unrecognizable to us today. This was the closing chapter of the Cretaceous period, the final age of the dinosaurs. For more than 150 million years, they had ruled the land, evolving into forms of breathtaking variety and dominance. Towering sauropods stretched their necks above forests to graze on treetops. Armored ankylosaurs lumbered like living tanks, their tails ending in bony clubs. Swift raptors, intelligent and agile, hunted in packs. And reigning supreme was Tyrannosaurus rex, the apex predator of its time, its massive skull and crushing jaws a symbol of raw power. It was not only the dinosaurs. The Earth itself was teeming with life. Flowering plants had spread across continents, painting landscapes with colour. Insects buzzed in uncountable numbers, pollinating blooms and providing food for countless animals. In the skies, early birds soared, while enormous pterosaurs, some the size of small planes, glided effortlessly on ocean winds. Mammals lived too, but they were small and unobtrusive, mostly nocturnal, scurrying through undergrowth and burrows, overshadowed by reptilian giants. The seas were no less extraordinary. Vast oceans brimmed with marine reptiles, mosasaurs and plesiosaurs, predators that could rival dinosaurs in size. Ammonites, with their spiral shells, floated in abundance. Fish swarmed in schools that shimmered under the sunlight filtering through clear blue waters. Coral reefs flourished, supporting a dazzling array of life. From the coastlines of ancient continents to the deep seas, Earth was bursting with ecosystems both stable and thriving. Climate during the late Cretaceous was warm and humid. Ice caps were absent and sea levels were high, creating shallow inland seas that cut across continents. In North America, the western interior seaway split the land into two halves, where marine life thrived alongside terrestrial giants. Tropical forests stretched close to the poles. It was a greenhouse world, lush and fertile, where life seemed unshakable. But hidden beyond Earth, in the vastness of space, destiny was on a collision course. For millions of years, life had risen, adapted and flourished, but survival was never guaranteed. Evolution can build wonders, but it cannot defend against the cosmos itself. Out in the darkness, a rock more than 10 kilometers wide, larger than Mount Everest, was traveling silently toward Earth. Its path was indifferent, its power unimaginable, and its target fixed. Despite their dominance, dinosaurs were not invincible. Their world, though rich, was already in delicate balance. Volcanic activity in what is now India, the Deccan Traps, had begun releasing lava and gases, altering the climate. Carbon dioxide levels were rising, oceans were slowly warming, and some ecosystems showed signs of stress. Certain groups of animals, like ammonites, had already begun to decline. But none of these shifts foretold the scale of what was to come. Life was resilient, adaptable, and used to change. To a casual observer in the Cretaceous, the world would have seemed eternal. Herds of hadrosaurs migrated across floodplains, their calls echoing in the distance. Packs of raptors darted through forests, feathers glistening under dappled sunlight. Vast flocks of pterosaurs wheeled overhead, their wings casting shadows across coastal cliffs. It was a golden age, a living world in full bloom. Yet all of this, the forests, the seas, the giants, was just one impact away from annihilation. The asteroid's approach was undetected. Dinosaurs, mammals, insects, and plants had no idea that the sky itself was about to fall. The rock that would end their reign had been travelling for millions of years, perhaps born from the collision of bodies in the asteroid belt, nudged into a fatal orbit by Jupiter's immense gravity. On Earth, nothing seemed amiss. The sun shone, oceans sparkled, forests whispered in the wind. Creatures went about their lives unaware that these were the last ordinary days in their world. The Cretaceous biosphere had no warning, no preparation, no defense. When the asteroid finally entered Earth's atmosphere, it must have streaked across the sky like a second sun, brighter than anything life had ever seen. Within seconds, it slammed into what is now the Yucatan Peninsula in Mexico, at a place we call Chicxulub. The moment of impact was beyond imagination. The asteroid struck at over 20 kilometers per second, faster than a bullet, faster than sound, faster than comprehension. The energy it released was equivalent to billions of Hiroshima-sized atomic bombs. In an instant, the asteroid vaporized, along with everything in its immediate path. A crater over 150 kilometers wide and 20 kilometers deep was carved into the Earth. Rock turned to vapor, oceans boiled, and forests within thousands of kilometers were ignited by thermal radiation. A shock wave roared outward at supersonic speed, flattening everything in its path. Earth itself rang like a bell. Giant tsunamis surged across oceans, drowning coastlines. The skies filled with debris, vaporized rock, molten droplets, and dust launched into the upper atmosphere. Within hours, the sun began to fade behind a veil of darkness. The age of dinosaurs had ended, though most of them did not yet know it. In the days and weeks that followed, Earth spiraled into chaos. The atmosphere thickened with ash and soot. Temperatures dropped dramatically as sunlight was blocked. Photosynthesis collapsed, plants died, and with them, the herbivores who fed on them. Predators soon starved in turn. Wildfires, triggered by falling debris, raged across continents, burning forests into wastelands. The oceans, poisoned by acid rain and deprived of oxygen, lost many of their inhabitants. It was a nuclear winter long before humans had even discovered fire. Dinosaurs' last day was not a day at all, but a cascade of months and years of devastation. By the end, 3/4 of all species on Earth were gone, including almost all the dinosaurs. Only their small feathered relatives, birds, would survive, carrying their legacy into the future. The asteroid's impact was instantaneous, but its consequences unfolded like a slow-motion apocalypse. What began as a blinding flash over the Yucatan Peninsula cascaded into a planetary collapse that would last for years. In the immediate aftermath, devastation was absolute near the crater. Forests for hundreds of miles were obliterated by shock waves and firestorms. Anything alive in that region was gone within moments. But the true catastrophe lay not in what happened at Ground Zero, but in what followed worldwide. The debris blasted into the sky did not simply fall back to Earth. Much of it was ejected into the stratosphere, where it spread around the planet. Tiny droplets of molten rock called tektites rained down across continents, glowing as they fell, igniting wildfires wherever they landed. These global firestorms consumed vegetation, releasing massive amounts of carbon dioxide and smoke. Night fell not just from dust, but from the haze of burning Earth itself. For weeks, the sky glowed red with heat and smoke. Then, slowly, darkness deepened. Sunlight became scarce as dust and soot blocked the skies. Daylight dimmed to a twilight gloom. Temperatures plummeted, and photosynthesis halted. Plants starved first. Grasses had not yet evolved, but flowering plants, ferns and conifers withered in the shadows. Forests that had stood for millions of years collapsed in a matter of months. Herbivores, deprived of food, were next. Great herds of hadrosaurs and ceratopsians dwindled to nothing, their calls silenced across the plains. Predators like Tyrannosaurus rex followed quickly, not because they lacked power, but because they lacked prey. Apex predators are always the first to fall when ecosystems unravel. In the oceans, plankton, the base of marine food webs, suffered catastrophic losses. With no sunlight to fuel them, they dwindled, and the entire chain of life in the sea collapsed. Ammonites, which had survived for hundreds of millions of years, vanished entirely. Giant marine reptiles like mosasaurs, once lords of the oceans, could not withstand the famine. Coral reefs, starved of their symbiotic algae, bleached and crumbled. Life itself was unravelling at its roots. This period, often described as an impact winter, may have lasted for months or even years. Temperatures dropped drastically. Acid rain fell from skies laced with sulphur. Even after the dust began to settle, greenhouse gases from wildfires and vaporized rock lingered, eventually swinging Earth back towards searing heat. First a freezing darkness, then a sweltering greenhouse. The climate swung violently, punishing survivors. For the dinosaurs it was too much. After ruling the Earth for over 150 million years, their dominance ended abruptly. By the end of this global winter, 3/4 of all species on Earth were extinct. Most non-avian dinosaurs perished. Only their feathered relatives, small, adaptable birds, endured. But not everything died. The story of the extinction is also the story of survival. Certain animals, small and versatile, managed to cling to life. Crocodiles survived, perhaps because of their semi-aquatic habits and ability to go long periods without food. Turtles, burrowers, and amphibians endured in niches where conditions remained bearable. And then there were the mammals. For tens of millions of years they had lived in the shadows of dinosaurs, small and nocturnal, eking out lives in the undergrowth. But these traits became their salvation. Being small meant they required less food. Being burrowers or nocturnal helped them escape temperature extremes. Many could eat a wide variety of foods, from seeds to insects, giving them resilience when specialized dinosaurs starved. When the dust finally cleared and Earth began to stabilize, these survivors emerged into a world emptied of its giants. For the first time in over 100 million years, ecosystems had no dominant rulers. The stage was set for new experiments in evolution. With the dinosaurs gone, mammals began to expand. At first they were still small, no larger than badgers or raccoons, but they quickly diversified. Some evolved into grazers, others into predators, and still others into tree dwellers. Over the next 10 million years, mammals spread into niches once occupied by dinosaurs, slowly building toward the great diversity we see today. Birds too, descendants of small feathered dinosaurs, flourished in the empty skies. Insects rebounded alongside flowering plants, rebuilding ecosystems from the ground up. Reefs eventually returned, rebuilt by corals. The Earth healed, but it was transformed. The age of dinosaurs had ended. The age of mammals had begun. The Cretaceous-Paleogene extinction is often seen as the most famous of all mass extinctions, not because it was the largest, the Permian was worse, but because it feels closest to us. It cleared the way for our own story. Without the asteroid, dinosaurs might still rule, and mammals might never have risen beyond small shadows in the night. It is a reminder of how fragile life's dominance can be. An entire dynasty of creatures, who reigned longer than humans have existed by 100-fold, was wiped away in what was, geologically speaking, an instant. And it reminds us of something else, that Earth's greatest threats often come from beyond. Unlike the slow processes of volcanic eruptions or climate shifts, the asteroid came from the stars, sudden and unstoppable. For all our power and intelligence today, humanity remains vulnerable to the same cosmic forces that once ended the age of giants. 74,000 years ago, long after the dinosaurs had vanished, and long before the rise of cities or written history, humanity walked the Earth. They were not yet the global rulers we know today. Our ancestors lived in small bands, scattered across Africa and Asia, surviving as hunter-gatherers. They tracked herds across savannas, fished rivers, and sheltered in caves. The world was already locked in the grip of an ice age. Vast glaciers covered much of the northern hemisphere, while the tropics offered havens of warmth and resources. But deep beneath the island of Sumatra in modern-day Indonesia, forces were building that would nearly erase humanity before it had the chance to spread. Hidden below forests and rivers, a massive chamber of magma swelled, pressurized by heat and gas, waiting for the moment when Earth itself could no longer contain it. What was about to happen was not just a volcanic eruption. It was a super-eruption, one of the largest explosions the planet has ever known. The Toba volcano was no ordinary mountain. It was part of a system of supervolcanoes, geological monsters that erupt not with cones of lava, but with cataclysmic blasts that reshape entire continents. Unlike typical volcanoes, which erupt and rebuild themselves over centuries, supervolcanoes release so much material that they collapse inward, leaving vast calderas tens of kilometers wide. For thousands of years before its eruption, Toba slumbered. Around its slopes, tropical ecosystems thrived. Early humans may have even hunted in its forests or fished its lakes, unaware that beneath their feet lay a ticking time bomb. Then, around 74,000 years ago, the pressure reached its breaking point. When Toba erupted, it unleashed a fury almost beyond imagination. In a single catastrophic event, it expelled 2,800 cubic kilometers of volcanic material, enough ash, rock and gas to bury entire countries. For comparison, this was nearly 5,000 times larger than the eruption of Mount St. Helens. Helens, in 1980, and hundreds of times more powerful than Krakatoa in 1883. The blast tore apart the mountain, sending shockwaves that flattened forest for hundreds of miles. Rivers boiled, lakes evaporated, and pyroclastic flows, avalanches of superheated gas and ash, raced across the land at speeds faster than a car, incinerating everything in their path. Any living creature within hundreds of kilometers had no chance of survival. The ash did not remain local. Carried by winds, it spread across South Asia, blanketing India in layers several meters thick. Fossil evidence shows that entire ecosystems were buried under choking clouds of dust. The skies darkened across continents as fine ash particles reached the upper atmosphere and began circling the globe. To those alive at the time, it must have seemed as though the world itself was ending. The eruption's true devastation came not just from ash, but from gases. Toba released enormous amounts of sulfur dioxide into the stratosphere, where it formed aerosols that reflected sunlight back into space. Almost overnight, Earth's temperature plummeted. Scientists believe that global temperatures may have dropped by 3 to 5 degrees Celsius on average, and in some regions far more. This sudden cooling, on top of an already ongoing ice age, created what is known as a volcanic winter. For years, sunlight was dimmed, crops and wild plants withered, animal populations crashed. Humanity, still fragile and few in number, found its survival in doubt. Genetic studies suggest that, at this time, human populations may have dropped to as few as a few thousand individuals worldwide, a bottleneck so severe that it left an imprint in our DNA. Nearly all humans alive today are descended from that small group of survivors. For our ancestors, the aftermath was brutal. Ash-choked rivers, poisoned soil, and collapsed roofs of shelters. Herds of animals migrated or died, leaving hunters with little to pursue. Families would have struggled to find food, huddling together against freezing nights, praying for the return of sunlight. For some, caves and coastal refuges offered sanctuary. Others perished in the darkness. The Toba eruption may have pushed humanity to the very brink, and yet it did not finish us. Somehow, scattered bands of Homo sapiens endured, in Africa, in South Asia, perhaps along coastal routes where fish and shellfish remained. These survivors carried within them the seeds of all future human civilization. In the centuries that followed, the climate slowly stabilized. Forests regrew, animals repopulated the plains, and humans spread once more. But the world had changed. Many species did not survive the cold snap. Human populations were never quite the same, reduced to a narrow genetic line. The Toba eruption remains one of the most powerful reminders in history that nature's fury is not just local, but planetary. It shows us how a single geological event can alter the course of life itself. The eruption of Toba was not merely an event, it was a crucible. For countless plants and animals, it was the end of the story. But for early humans, it was a trial of survival so severe that it shaped the destiny of our species forever. When Toba unleashed its fury, humanity was still young. Homo sapiens had emerged in Africa only tens of thousands of years earlier and had just begun spreading into Asia. They lived in small hunter-gatherer bands, perhaps numbering only a few hundred individuals per group. They possessed stone tools, fire, and language, but they lacked the protection of agriculture or permanent settlements. Their resilience lay in adaptability and cooperation, not in technology. The eruption threatened to erase even this fragile foothold. Ashfall smothered vast regions, making hunting nearly impossible. Herd animals migrated away from devastated plains, leaving hunters with empty landscapes. Rivers and lakes were poisoned with volcanic dust. Fish populations collapsed, and edible plants withered under ash and cold. In South Asia, layers of ash meters thick testify to the scale of devastation. Archaeological evidence suggests that entire ecosystems were buried alive. For humans living there, survival would have been almost impossible. Populations dwindled. Genetic studies of modern humans reveal something extraordinary. At some point in our past, our species' genetic diversity shrank dramatically. Today, all humans are far more closely related than would be expected if we had maintained large, stable populations throughout history. Scientists call this the genetic bottleneck. One leading hypothesis ties this bottleneck to the Toba eruption. It suggests that the supervolcano reduced the global human population to as few as several thousand breeding individuals. Entire lineages were lost, and only a narrow genetic strand of humanity survived. This is why, despite our vast numbers today, we share such close genetic similarity compared to other primates. While the exact numbers remain debated, the idea is chilling. We were nearly erased, our species clinging to existence by the thinnest of threads. How did anyone survive at all? The answer may lie in geography and resourcefulness. In Africa, some regions were less affected by the eruption. Coastal areas provided fish, shellfish, and seaweed, which remained relatively stable food sources even during volcanic winters. For small human bands, access to the ocean may have been the difference between life and death. Caves offered shelter from ash and cold. Fire provided warmth and the means to cook scarce food. Cooperation within groups ensured that resources, however meagre, could be shared. These survival strategies were not new, but under the conditions after Toba, they became essential. There is also evidence that humans displayed remarkable ingenuity even then. Archaeological sites in Africa show continued use of complex stone tools during the period of the eruption. This suggests that, despite the crisis, pockets of humans maintained their traditions and knowledge. Culture, even in its earliest forms, may have been humanity's lifeline. For generations after the eruption, the world remained a difficult place. Sunlight was dimmed for years, perhaps decades. Growing seasons shortened. Herds took centuries to recover. Those who lived through this time would have known constant hunger, constant migration, constant loss. Infant mortality must have been devastatingly high. The weak and elderly were often left behind, and yet there were stories of resilience. Each surviving group carried not only its genes but its knowledge. Which plants could still be eaten, which caves offered warmth, how to follow the stars to new hunting grounds. These were the lessons passed down, the quiet wisdom that ensured survival. It was in this crucible that humanity was hardened. Fragility forced ingenuity, scarcity forced cooperation, crisis forced memory, the kind of cultural transmission that would later blossom into full civilizations. As the climate gradually stabilized over centuries, the survivors began to spread again. Forestry grew, rivers cleared, herds returned to grasslands. With the return of resources, population slowly increased. The genetic bottleneck left its mark, not in visible scars but in our shared ancestry. Every person alive today may be descended from those few thousand individuals who endured the shadow of Toba. The eruption almost ended us, but instead it united us. And there was another gift hidden in survival: resilience. The humans who spread out after Toba carried with them the lessons of endurance, the instincts of adaptability, and the traditions of cooperation. These traits would define us as a species. The Toba eruption serves as one of Earth's starkest warnings. It shows how fragile human life is in the face of natural catastrophe. A single geological event reshaped our species' trajectory, forcing us through a bottleneck that nearly ended us. And yet, it also shows our strength. Unlike many species that perished, humans endured. Not because we were the strongest or the most numerous, but because we were adaptable. Because we could change our behavior, work together, and innovate. Today, we face new challenges: climate change, pandemics, technological risks. And the story of Toba whispers across time. Survival depends not on denial, but on adaptation. Humanity exists because we once endured a winter of ash. The Toba super-eruption was not the end of the world, but it was the closest our young species had ever come to vanishing. It was one of the 5 times the world nearly ended, and one of the reasons we stand here today to tell its story. The year was 1347. Europe was a patchwork of kingdoms and city-states, its people living in bustling towns, farming villages and walled cities. Cathedrals rose above marketplaces, trade routes stretched across continents, and merchants carried goods from the far reaches of Asia and Africa. It was an age of faith and superstition, of knights and peasants, of wealth and famine. Few could have imagined that within a few short years this vibrant but fragile society would be hollowed out by a force invisible to the eye, a silent killer carried by rats and fleas, hidden in the holds of trading ships. Life in the 14th century was precarious but thriving. Agricultural innovations had increased food production. Populations had grown rapidly in the preceding centuries, leading to crowded cities filled with artisans, merchants, and travellers. Trade flowed through the Silk Road, linking Europe to the Middle East and Asia. Ships carried spices, silk, and precious metals across the Mediterranean and the Black Sea. But alongside goods, these networks carried something else: pathogens. The bacterium Yersinia pestis, lurking in the blood of fleas, rode on the backs of black rats that infested merchant ships. It had already swept through Asia, devastating communities, and now it was heading for Europe. In October 1347, 12 Genoese ships arrived in the Sicilian port of Messina. What they carried would change history. The crews were dead or dying, their bodies covered in black swellings, their breath ragged with fever. The city panicked, driving the ships away, but it was too late. The disease had landed. From Sicily, the plague spread with terrifying speed. It moved along trade routes, carried by merchants, soldiers, and pilgrims. Within weeks, it reached mainland Italy, then France, Spain, and beyond. By 1348, it was in England. By 1350, it had swept through most of Europe. No city, no village, no monastery was safe. Victims developed sudden fevers, chills, and vomiting. Painful swellings appeared in the armpits, neck, and groin. Buboes, filled with blood and pus. Many also suffered from coughing fits that sprayed blood, a sign of the pneumonic form of the disease, which spread directly from person to person. Others developed dark blotches on their skin as internal bleeding poisoned their flesh. Death often came within days, swift and merciless. The disease killed without regard for wealth, age, or status. Kings and peasants, priests and beggars, merchants and farmers, all were equally vulnerable. Entire families died in days. In some towns, half the population vanished. Eyewitnesses wrote of streets filled with corpses, of carts hauling the dead to mass graves, of priests too overwhelmed to give last rites. Fear gripped the continent. Some people turned to prayer, believing the plague was God's punishment for sins. Flagellants marched from town to town, whipping themselves in hopes of appeasing divine wrath. Others blamed outsiders, particularly Jewish communities, leading to horrific pogroms and massacres. Superstition flourished as people burned incense, carried charms, or fled to the countryside in desperate attempts to escape the invisible terror. But there was no escape. The plague travelled faster than fear. Wherever trade and people moved, the disease followed. The numbers are almost beyond comprehension. Between 1347 and 1351, the Black Death killed an estimated 25 to 50 million people in Europe, between a third and half the population. In some cities, death rates approached 70%. Entire villages disappeared. Fields went untilled, businesses collapsed, and churches were overwhelmed. Europe had seen wars and famines before, but never devastation on this scale. It was as if the very structure of society was crumbling under the weight of death. For survivors, the world became unrecognizable. Streets were empty, houses abandoned, farms overgrown. Children wandered without parents, monks without abbots, rulers without kingdoms. A sense of doom spread. Many believed it was the end of days. The plague's silence was deceptive. It had no armies, no banners, no visible face. And yet, it conquered kingdoms more swiftly than any warlord. It was a reminder that humanity's greatest threats are not always external invaders, but the microscopic killers we cannot see. The Black Death was not just a disease. It was an apocalypse in miniature, one of the times the world nearly ended. The plague did not simply kill millions. It transformed the very fabric of the world it ravaged. When the worst waves passed in the early 1350s, Europe was a scarred continent, its fields empty, its cities hollowed, its people haunted. But from the devastation rose new realities. The Black Death was not only a tragedy, it was also a turning point. When half the population of a village dies, the survivors cannot continue life as before. Across Europe, farmland lay abandoned. Crops rotted in fields, orchards withered, and animals wandered without caretakers. In England alone, chroniclers wrote of entire villages deserted, their houses falling into ruin, their churches empty. This collapse of labour created ripple effects across society. For centuries, peasants had been bound to the land under systems of feudalism. They owed service to lords, working fields in exchange for protection. But now, with so few workers left alive, peasants discovered something remarkable. Their labour was suddenly valuable. Lords could no longer demand endless toil without compensation. Survivors began to negotiate higher wages, shorter hours, and freedom to move in search of better conditions. The Black Death, unintentionally, undermined the rigid structures of medieval society. In its ashes, the seeds of change were sown. With fewer people alive, demand for goods decreased, but wages for labour increased. This strange balance created both hardship and opportunity. For poor survivors, life after the plague could be better than before: more land to farm, more food to eat, more negotiating power with landlords. For wealthy elites, the world grew uncertain, their dominance weakened. In some regions, authorities tried to resist change. England's rulers, alarmed by rising wages, issued the Statute of Labourers in 1351, attempting to freeze wages at pre-plague levels, but the law was nearly impossible to enforce. Workers simply refused or moved elsewhere. Tensions erupted into rebellions, like the Peasants' Revolt of 1381, where commoners demanded fairer treatment. The plague, without intention, had set Europe on the path toward a more flexible, modern economy. Death on such a scale reshaped the culture of Europe. Art, literature, and religion became obsessed with mortality. The image of the danse macabre, the dance of death, appeared in paintings and poems, showing skeletons leading kings, peasants, and priests alike into the grave. It was a grim reminder that death spared no one. Religion both strengthened and fractured. Many turned to the church in desperation, seeking meaning in the tragedy. Others grew disillusioned, questioning how a merciful God could allow such suffering. Clergy had died in enormous numbers, leaving parishes leaderless. New religious movements rose, some heretical, some reformist, all seeking to explain a world turned upside down. Superstition thrived. People carried charms, consulted astrologers, or blamed minorities for their suffering. The Jewish communities of Europe in particular faced horrific persecution, accused falsely of poisoning wells or spreading disease. Thousands were massacred in pogroms, a tragic echo of fear's cruelty. Yet alongside fear grew curiosity. The plague forced some, to seek rational explanations, to study disease, to question old assumptions. It was not yet modern science, but it was a step toward it. The Black Death exposed the limits of medieval medicine. Doctors relied on humours, astrology, or superstition, but none of it stopped the plague. Treatments failed, and the authority of physicians crumbled, but the failure itself planted seeds. Slowly, healers began to turn toward observation and evidence. Cities introduced early forms of quarantine, isolating ships and travellers for 40 days, quaranta in Italian, before allowing them to enter. Venice built special hospitals called lazarettos to contain outbreaks. These were primitive steps, but revolutionary, the recognition that disease could spread through contact and that separation could prevent it. The plague did not create modern medicine, but it forced the first glimpses of it. Centuries later, these lessons would evolve into germ theory, vaccines, and public health. By the late 14th century, the worst waves of plague had passed, though it returned periodically for centuries. Europe's population would not recover to pre-plague levels for nearly 200 years. But the survivors lived in a changed world. Feudalism weakened, wages rose, cities grew in new ways. The cultural obsession with death gave rise to both darker art and, eventually, the creativity of the Renaissance. Religion fractured, but also reformed. Medicine faltered, but also advanced. The Black Death nearly ended the medieval world, and in doing so, it cleared the way for the modern one. The story of the plague reminds us that humanity's greatest threats are often invisible. A microbe smaller than the eye can see reshaped continents, toppled systems, and transformed history. It also reminds us that endings and beginnings are intertwined. From despair came resilience, from collapse came rebirth. The world nearly ended in the 14th century, but it did not. And the survivors, scarred, changed, but alive, built a new chapter of civilization. The year was 1918. The world was already bleeding. The First World War, the war to end all wars, had dragged on for 4 brutal years. Europe's landscapes were scarred by trenches, its cities rationed and weary, its young men slaughtered in numbers that defied imagination. Soldiers trudged through mud, barbed wire, and poison gas. Civilian populations endured hunger, fear, and loss. Humanity believed it had already seen its darkest hours. But as the war neared its end, another enemy appeared, one that no bullet, no trench, no treaty could stop. It did not march under banners, it carried no guns. It was smaller than the eye could see, but deadlier than any army. The Spanish flu of 1918 arrived quietly, but within months it would kill more people than the war itself. The earliest cases were reported in the spring of 1918, though its true origin remains debated. Some point to Kansas, where soldiers at Camp Funston fell, ill with an unusual flu. Others trace it to China or Europe, carried by labourers and troops moving across continents. Wherever it began, its spread was unstoppable. Soldiers, already weakened by war, became perfect carriers. Troop ships, crowded and unsanitary, ferried the virus across the Atlantic and into Europe. Unlike typical influenza, which often claims the very young and the elderly, this flu was different. It struck hardest at the strong and healthy, particularly young adults aged 20 to 40. Soldiers in their prime collapsed within days, sometimes hours. What began as fever and aches often escalated into severe pneumonia. Many victims turned blue as their lungs filled with fluid, gasping desperately for air until they suffocated. By summer, the first wave had spread across Europe, North America, and Asia. It was deadly, but not yet apocalyptic. Many assumed it would fade like previous influenza outbreaks. They were wrong. In the autumn of 1918, the virus mutated into a far more lethal form. This second wave was catastrophic. Mortality rates soared. In some cities, thousands died in a single week. The virus spread like wildfire through military camps, schools, and factories. In Philadelphia, officials ignored warnings and held a massive parade to sell war bonds. Within 3 days, hospitals were overwhelmed. Within a week, thousands were dead. Coffins ran out. Bodies piled in temporary morgues. Mass graves were dug by the dozens. In India, the flu killed millions, striking with particular cruelty at those weakened by famine and colonial poverty. In remote villages, entire families perished, their houses left silent. Across the globe, from Africa to South America, the flu spared no continent, no community. The ongoing world war made the disaster worse. Troop movements accelerated the spread. Governments censored news to maintain morale, hiding the scale of the outbreak. Soldiers already weakened by gas attacks, malnutrition, and stress became easy prey for the virus. In the trenches of France, men who had survived years of shelling now died gasping for breath in crowded field hospitals. The flu was nicknamed the Spanish flu, not because it began in Spain, but because Spain, neutral in the war, did not censor its newspapers. Reports from Madrid revealed the scale of the outbreak, while warring nations kept their suffering secret. The name stuck, but the flu was everywhere. The speed of death was shocking. Healthy young men and women could be fine in the morning and dead by nightfall. Doctors were helpless. There were no antivirals, no vaccines, no antibiotics to treat secondary infections. Treatments ranged from whiskey and aspirin to folk remedies, none of which worked. In some cases, aspirin overdoses, recommended at doses now known to be toxic, may have worsened the crisis. Families watched helplessly as their loved ones turned blue, coughed up blood, and slipped away. Hospitals overflowed, schools and theatres closed, and public gatherings were banned in desperation. By the end of 1918, the Spanish flu had become one of the deadliest pandemics in human history. Historians estimate that between 50 and 100 million people died worldwide, more than the entire death toll of the First and Second World Wars combined. In some regions, entire communities lost up to half their population. Survivors spoke of towns with no doctors, cities where carts carried corpses by the hundreds, and ships where sailors died so quickly they were buried at sea before the voyage ended. Unlike the plague centuries earlier, this was not an age of superstition. Science existed, but it was powerless. Humanity had entered the modern era of medicine, yet it was still defenseless against a microbe it could not see. The Spanish flu was a global catastrophe, a reminder that even in an age of steel and industry, humanity remained vulnerable to the smallest of enemies. When the Spanish flu finally loosened its grip in 1919, the world it left behind was changed forever. The war had ended, but peace felt hollow. Cities were littered with the memories of lost lives. Families were broken, workforces decimated, and communities silenced by grief. The pandemic had been brief, scarcely 2 years, but in that time it had reshaped the course of the 20th century. Historians estimate that between 50 and 100 million people died worldwide, roughly 1 in every 20 humans alive at the time. No corner of the globe was untouched. In India alone, tens of millions perished. In small Pacific islands, entire villages disappeared. Even the most remote Arctic communities lost members to the flu. It was not only the numbers, but the demographic profile that shocked observers. Unlike most influenza strains, this one targeted the young and healthy. Men and women in the prime of life, workers, parents, soldiers, were its chief victims. The result was a unique wound. Families lost breadwinners, societies lost leaders, and economies lost their strongest members. Where war had cut down soldiers in uniform, the flu cut down civilians at home. Survivors carried not only memories of loss, but a deepened awareness of fragility. Many who lived through the flu spoke of watching entire households vanish in days. Children were left orphans, parents buried their own sons and daughters, and communities carried grief too large to fully express. Unlike the visible destruction of war, battlefields, craters, ruins, the flu's devastation was intimate, hidden in homes and hospitals. There was also silence. Governments, eager to move past the war and its horrors, often downplayed or ignored the flu in public memory. Newspapers rarely gave it the prominence it deserved, and official histories of the early 20th century treated it as a footnote beside the war. For decades, the greatest pandemic in modern history remained strangely forgotten, remembered only in family stories and medical records. Yet, the flu did shape societies in subtle but lasting ways. Workforces weakened by death and illness demanded adjustments. In some regions, wages rose as employers competed for fewer workers. In others, poverty deepened as families lost their providers. The balance varied from country to country, but everywhere the flu altered demographics. Public gatherings, once taken for granted, became moments of fear. Cities introduced new health policies, closing schools during outbreaks, restricting large events, and expanding public health departments. The very idea of public health infrastructure began to grow. The world recognized, if slowly, that disease was not only a personal matter, but a societal threat. At the time of the Spanish flu, medical science was advanced enough to understand germs, but lacked the tools to fight them. There were no antivirals, no vaccines, no antibiotics for bacterial complications like pneumonia. Doctors could do little more than provide supportive care. This helplessness sparked a determination to improve. In the decades that followed, the memory of the flu drove investment in medical research. The 1920s and 1930s saw advances in virology, the study of viruses. By mid-century, antibiotics revolutionized treatment of secondary infections. Vaccines against influenza strains were developed during World War II, offering for the first time a way to prevent widespread outbreaks. The pandemic had shown humanity its vulnerability. Medicine responded by pushing towards strength. The Spanish flu offers haunting lessons for the present. It showed how global travel accelerates pandemics, how censorship and denial worsen crises, and how unprepared systems collapse under pressure. The same patterns have repeated in later outbreaks, from SARS to COVID-19, each echoing 1918's warnings. It also reminds us of resilience. Humanity endured, scarred but not broken. Communities rebuilt, families adapted, and societies moved forward. But the cost was immense. Tens of millions of lives lost in silence. Perhaps the strangest legacy of the Spanish flu is how quickly it was forgotten. The war dominated headlines, literature, and memory. The flu, despite killing far more, was rarely discussed in the years after. Survivors carried personal grief, but collective memory pushed it aside. It was only in recent decades that historians and scientists began to reclaim its story, recognizing it as one of the greatest catastrophes in human history. This silence is a lesson in itself. Humanity does not always remember what nearly ended it. Sometimes, the greatest threats vanish into whispers, overshadowed by louder events. Yet the Spanish flu remains a ghost in our collective past, a reminder of fragility and a warning for the future. The Spanish flu of 1918 nearly ended the world as people then knew it. It toppled families, silenced cities, and reshaped societies. And though it faded from memory, its shadow still lingers, teaching us that our survival has always been more precarious than we like to believe. On August 6, 1945, The sky above Hiroshima was clear. It was a bright summer morning, the kind of day when schoolchildren marched to classes and workers hurried through the streets. At 8:15 a.m., a single American bomber, the Enola Gay, released its payload, a bomb nicknamed Little Boy. In less than a minute, the world changed forever. The bomb exploded with a force equivalent to 15,000 tons of TNT, instantly flattening much of the city. A blinding flash seared shadows into walls. Temperatures at the epicenter reached over 4,000 degrees Celsius, hot enough to vaporize human bodies. A fireball rose, forming the first mushroom cloud in history. Tens of thousands were killed in an instant. Tens of thousands more staggered through the ruins, burned, blinded, or poisoned by radiation. 3 days later, another bomb, Fat Man, was dropped on Nagasaki. Again, an entire city was devastated. By the end of 1945, more than 200,000 people had died from the two bombings. For the first time in history, humanity had created a weapon capable not only of destroying cities, but of threatening civilization itself. The nuclear age had begun. The bombs ended World War II, but they also introduced a new terror. Humanity had always lived under threats from nature: volcanoes, asteroids, plagues. Now, for the first time, humans themselves had created a force capable of ending the world. In the years that followed, nuclear weapons multiplied. The United States tested bigger and deadlier bombs. In 1949, the Soviet Union detonated its first atomic weapon, ending America's monopoly. The Cold War became not just a clash of ideologies, but a standoff of apocalyptic potential. By the 1950s, hydrogen bombs, thousands of times more powerful than the Hiroshima bomb, had been built. A single one could annihilate a metropolis. With stockpiles growing, both superpowers possessed enough firepower to destroy the planet many times over. Ordinary people lived in its shadow. In the United States, schoolchildren practiced duck and cover drills, hiding under desks as if thin wood could shield them from nuclear fire. In the Soviet Union, citizens were taught evacuation routes and survival techniques that offered little real protection. Governments built bunkers, families stocked fallout shelters, and civil defense became a way of the life. The fear was not abstract. Nuclear tests filled the atmosphere with radiation. Soldiers were sometimes stationed near test sites, watching mushroom clouds rise like terrifying suns. Islanders in the Pacific were displaced as their homes became test grounds. Farmers thousands of miles away found radioactive isotopes in their soil. The nuclear age touched not just politics, but the very air, water, and food of the world. The danger was not only in intentional war, but in accidents and miscalculations. Early warning systems were primitive. False. Alarms occurred. In 1956, radar errors briefly suggested a massive Soviet strike, nearly prompting retaliation. In 1960, a moonrise was mistaken for a missile launch. Again and again, humanity came within minutes of triggering catastrophe by mistake. The most famous moment came in 1962 during the Cuban Missile Crisis. For 13 days, the United States and the Soviet Union stood on the brink of nuclear war. Missiles in Cuba, blockades at sea, and tense negotiations pushed the world closer to annihilation than ever before. Many feared each sunrise might be the last. In the end, diplomacy prevailed, but the crisis revealed how fragile peace was in a nuclear world. In 1947, scientists who had worked on the Manhattan Project created the Doomsday Clock, a symbolic representation of how close humanity was to self-destruction. Set at 7 minutes to midnight, the clock moved forward or back depending on global tensions. Each tick closer to midnight represented a step toward apocalypse. By the early 1950s, with hydrogen bombs tested and arms races escalating, the clock crept forward. Humanity now measured its survival not just in years or decades, but in symbolic minutes. The nuclear age was, and remains, an age of paradox. The same weapons that could destroy the world also prevented war between superpowers through the logic of mutually assured destruction, MAD. The idea was simple. If one side launched, the other would retaliate, and both would be obliterated. The threat of annihilation became the foundation of uneasy peace. But peace built on terror is fragile. Accidents, miscommunications, or reckless leaders could tip the balance at any moment. Humanity now lived seconds from midnight, Every day, every hour, the nuclear bomb was not just a weapon, it was a mirror, forcing humanity to confront its own power, its own recklessness, and its own fragility. For the first time, the world nearly ended not by nature's hand, but by our own. The mushroom clouds over Hiroshima and Nagasaki were the prologue. The real story of the nuclear age unfolded not in battlefields, but in tense control rooms, silent submarines, and the minds of leaders who held the power to end the world with a single order. By the mid-20th century, the United States and the Soviet Union were locked in a race to build ever more destructive arsenals. Each test brought bigger blasts, new delivery systems, and more sophisticated strategies. By the 1960s, both powers had amassed thousands of warheads, mounted on intercontinental ballistic missiles capable of crossing oceans in under 30 minutes. The doctrine of mutually assured destruction, MAD, dictated global security. The idea was chillingly simple. Neither side would launch a first strike because they knew the other would retaliate, ensuring total annihilation. Peace depended not on trust, but on terror. In October 1962, the world came closer to midnight than ever before. American reconnaissance planes discovered Soviet missiles being installed in Cuba, just 90 miles from US shores. President John F. Kennedy demanded their removal and imposed a naval blockade. Soviet ships carrying missiles approached the blockade line. For 13 days, humanity held its breath. US generals urged a strike. Soviet forces on the ground were ready to launch if attacked. Unknown to Washington at the time, Soviet submarines armed with nuclear torpedoes patrolled near the blockade, one captain even considering launch when depth charges rattled his vessel. He was stopped only when fellow officer Vasily Arkhipov refused to consent. One man's decision may have saved the world. Ultimately, diplomacy prevailed. The Soviets agreed to withdraw missiles from Cuba, and the US quietly agreed to remove its own missiles from Turkey. The world exhaled, but the crisis revealed just how thin the line was between survival and annihilation. The danger was not only in deliberate war, but in mistakes. Technology, designed to protect, often misled. In 1979, a training tape was accidentally loaded into a US warning system, showing a massive Soviet attack on screens. Command centers scrambled bombers into the air before realizing it was a simulation. In 1983, Soviet early warning satellites falsely detected incoming US missiles. The duty officer, Stanislav Petrov, faced an impossible choice: report the launches and trigger retaliation, or trust his instincts that it was a malfunction. He chose not to escalate. He was right. It was a reflection of sunlight on clouds. His calm decision likely prevented nuclear war. Again, in 1995, Russia's radar mistook a scientific rocket launched from Norway for a potential US missile. For minutes, the Russian nuclear briefcase was opened, and leaders considered response. Only at the last moment did analysts realize it was harmless. Each false alarm was a brush with apocalypse. Humanity survived not because systems were perfect, but because individuals hesitated, doubted, or refused to push the button. Generations lived with the constant fear of annihilation. The doomsday clock, maintained by scientists, ticked closer to midnight as arsenals grew. In the 1980s, with over 60,000 nuclear warheads worldwide, the world was one miscalculation away from destruction. Films, books, and art reflected the dread. Children drew mushroom clouds in classrooms. Protesters marched with banners calling for disarmament. Leaders spoke of nuclear winter, the theory that even a limited exchange could blanket Earth in smoke and ash, blocking sunlight, collapsing agriculture, and starving billions. The apocalypse was no longer a distant myth. It was a technical possibility scheduled not by prophecy but by policy. And yet, war never came. Diplomacy, arms control treaties, and deterrence kept the peace, however uneasy. Treaties like SALT, START, and the Nuclear Non-Proliferation Treaty slowed the arms race. Inspectors checked silos, satellites monitored. Launches and dialogue, however tense, maintained communication. But peace built on the edge of catastrophe is fragile. Every close call revealed the same truth. Survival was often the result of chance, caution, or one individual's moral courage. The nuclear age remains one of the clearest examples of how humanity nearly ended itself. Unlike the asteroid or the supervolcano, this was not nature's doing. It was our own. Humans created weapons so powerful that a single decision, a single error, could erase civilizations. The Great Dying had been caused by volcanoes. The dinosaurs had fallen to a rock from space. But the nuclear age showed something new. For the first time, humanity became its own existential threat. The bombs were built to deter war, but in building them, we placed civilization on the edge of annihilation. We lived seconds from midnight, and still do. The story of Earth's near endings has often been told in fire and ash, in sudden blows from space or catastrophic eruptions. But the crisis we face today is different. It is not an asteroid hurtling from the heavens or a supervolcano tearing the sky apart. It is slower, quieter, but just as dangerous. It is a threat born not of chance but of our own hands. The danger is climate change, and it has already begun. For most of human history, our impact on the planet was small. Hunter-gatherers lived in balance with ecosystems. Early farmers cleared forests, but the Earth absorbed their changes. Even great civilizations like Rome or China left scars that healed with time. But the Industrial Revolution in the 18th century changed everything. The discovery of coal, oil, and gas unleashed new power. Factories rose, cities swelled, machines roared. Humanity learned to burn the stored sunlight of ancient ages, fossil fuels, releasing carbon that had been locked underground for millions of years. For a while, it seemed like progress without cost. Lights glowed at night. Trains and ships connected continents, and wealth grew. But each coal furnace, each steamship, each engine released invisible gases into the sky. Carbon dioxide, methane, nitrous oxide, greenhouse gases that trap the sun's heat. At first, the Earth absorbed them. But as centuries passed, concentrations rose to levels not seen in hundreds of thousands of years. By the 20th century, the balance was breaking. By the 21st, it had tipped. The numbers tell the story. Since the late 19th century, global average temperatures have risen by more than 1.2 degrees Celsius. That may sound small, but the Earth's climate is a finely tuned system. A shift of 1 degree can mean the difference between ice ages and warm eras. Glaciers retreat. Arctic sea ice vanishes. Oceans warm and expand, driving sea levels higher. Storms intensify. Droughts lengthen. Heat waves grow deadlier. Wildfires consume forests from California to Australia. Species vanish as habitats change faster than they can adapt. We are witnessing the 6th mass extinction, not from a rock or a volcano, but from our factories, cars, and power plants. Life is resilient, but it is not invincible. As temperatures climb, ecosystems unravel. Coral reefs, home to a quarter of marine life, bleach and die when oceans warm by just a few degrees. Tropical rainforests, lungs of the planet, face deforestation and fires that could transform them into savannas. Polar bears, penguins, and countless species lose their icy homes. Scientists warn that we are losing species at rates 100 to 1,000 times higher than natural background levels. Each loss is not only a tragedy, but a chain reaction. When one species vanishes, others that depend on it falter, creating cascades of collapse. The intricate web of life, woven over millions of years, frays strand by strand. Climate change is not only about polar bears or forests, it is about people. Rising seas threaten to swallow island nations and flood coastal cities where hundreds of millions live. Droughts devastate crops, driving famine. Heat waves kill the elderly and the poor. Wars and conflicts, fueled by scarcity, already show signs of rising. Refugees flee not only violence but failing ecosystems. For the first time, humanity faces a global crisis of its own making, one that does not strike in an instant, but grinds relentlessly year by year, decade by decade. Unlike the asteroid that ended the dinosaurs, climate change unfolds slowly. That is its danger. We see its signs: melting glaciers, stronger storms. But we adapt, adjust, normalize. Each year feels like the new normal until the line between stability and collapse is crossed. It is an apocalypse in slow motion, and unless action is taken, it may be remembered as the moment when humanity pushed Earth into its next great dying. The Earth has nearly ended before, by fire, by ice, by plague, by war. But this time the threat is us. The story of climate change is not just about rising temperatures, it is about thresholds. Invisible lines in Earth's systems that, once crossed, can trigger irreversible change. Scientists call these tipping points, and they represent the moment when gradual warming transforms into unstoppable cascades. If the Permian extinction and other ancient catastrophes were sudden blows, today's crisis may become death by 1,000 cuts, until one cut too many brings collapse. At the poles, glaciers and ice sheets act as Earth's mirrors, reflecting sunlight back into space. As they melt, dark ocean water and rock absorb more heat, accelerating warming. This feedback loop, called the albedo effect, is already visible. Arctic sea ice shrinks each summer to record lows. The Greenland ice sheet loses billions of tons annually. If Greenland were to melt completely, sea levels would rise by more than 7 meters, drowning coastal cities from New York to Shanghai. Antarctica holds even greater potential. Vast ice shelves, weakened by warming waters, are cracking and collapsing. The Thwaites Glacier, nicknamed the Doomsday Glacier, could alone raise seas by meters if it fails. Scientists warn that its retreat may already be unstoppable. In Siberia, Alaska, and Canada, frozen soils called permafrost are thawing. Locked within them is more carbon than exists in the atmosphere today, stored for millennia. As the ground warms, microbes awaken, releasing carbon dioxide and methane, a greenhouse gas many times more potent than CO2. Villages sink as the ground collapses. Ancient animal carcasses emerge, thawed from ice. The release of methane from permafrost could tip the climate into runaway warming, echoing the conditions that may have fueled the Great Dying 250 million years ago. Forests are not only lungs but regulators of climate. The Amazon rainforest, vast and vital, produces moisture that fuels rainfall across South America. But deforestation and rising temperatures push it toward a tipping point. If too much forest is lost, the system could collapse, transforming into a dry savanna. Billions of tons of carbon would be released, and one of Earth's greatest stabilizers would become a source of chaos. Similarly, boreal forests in the north suffer from pest outbreaks and fires. Once sinks of carbon, they risk becoming emitters. The planet's green shield weakens even as we need it most. Oceans absorb heat and carbon, buffering us from worse warming. But they are not infinite sponges. As waters warm, circulation patterns weaken. The Atlantic Meridional, the great conveyor belt that carries warm water north and cold water south, shows signs of slowing. If it collapses, Europe could freeze even as the tropics overheat. Weather patterns worldwide would shatter, destabilizing agriculture and rainfall for billions. At the same time, oceans grow more acidic, dissolving shells and corals. Reefs, nurseries of the seas, are dying. Fisheries that feed millions collapse, leaving hunger in their wake. Climate change is not only physical, but social. Droughts drive farmers from their land. Rising seas swallow villages. Scarcity fuels conflict. Already, studies link climate stress to wars in Syria, migrations across Africa, and tensions in South Asia. If warming continues, the refugee crises of today may become floods of humanity tomorrow, destabilizing nations and continents. Economic systems, too, face tipping points. Insurance markets collapse under constant disaster claims. Food prices spike as harvests fail. Entire industries face extinction, while new ones struggle to emerge. Modern society, so complex and interconnected, proves fragile under sustained strain. The question haunts scientists: are we creating the conditions for the sixth mass extinction? The parallels with past catastrophes are chilling. During the Great Dying, volcanic carbon warmed the planet. Oceans lost oxygen, and species vanished. Today, our smokestacks and engines mimic those volcanoes. The difference is speed. We are pouring carbon into the atmosphere far faster than natural processes ever did. Already, species vanish daily. Coral reefs, amphibians, insects, countless small threads of the web of life are snapping. Each loss is easy to ignore until the web itself collapses. If trends continue, the 21st century could rival the worst die-offs in Earth's history. Unlike past extinctions, this one is not inevitable. Humanity holds both the match and the extinguisher. Renewable energy, reforestation, and carbon capture offer hope. Policies and treaties can steer us away from catastrophe, but time is short. Each year of inaction locks in more damage, pushes systems closer to tipping points. The climate crisis is not a distant future. It is unfolding now. Floods, Fires, storms, and extinctions remind us that the edge is near. The choice is whether we step back or fall. The story of climate change may yet become another chapter in Earth's near endings. But unlike the asteroid or the supervolcano, this chapter is being written by us, and only we can decide how it ends. For all our progress, for all our technology, humanity still lives on a fragile world spinning through a dangerous universe. The catastrophes of the past, the asteroid that ended the dinosaurs, the volcanic winters, the plagues, remind us that survival is never guaranteed. And even today, threats linger beyond our atmosphere, waiting in the vast silence of space. The future, like the past, holds dangers that could end our story in a heartbeat. Every day, Earth is bombarded by debris from space. Most of it burns harmlessly in the atmosphere as shooting stars. But history has shown that sometimes larger bodies make it through. 66 million years ago, one such impact wiped out the dinosaurs. It was not the first asteroid to strike Earth, and it will not be the last. Astronomers track thousands of near-Earth objects, NEOs, asteroids and comets whose orbits bring them close to our planet. Some are miles wide, large enough to cause global devastation if they hit. Even smaller ones, a few hundred meters across, could destroy entire cities or regions. The 1908 Tunguska event in Siberia flattened thousands of square kilometers of forest, likely caused by an object less than 100 meters across. If such an impact occurred over a city today, millions could die. Governments and scientists have begun to take the threat seriously. Space agencies track potential impactors, developing strategies to deflect or destroy them. NASA's DART mission recently demonstrated the possibility of altering an asteroid's course. But detection is imperfect, and resources are limited. A rock from the void could still surprise us, as it did the dinosaurs. Asteroids are not the only cosmic killers. The universe is filled with violent events that could threaten Earth. Among the most feared are gamma-ray bursts, intense flashes of high-energy radiation caused by collapsing stars or neutron star mergers. If one occurred close enough to Earth, its radiation could strip away our atmosphere's ozone layer, exposing the surface to deadly ultraviolet rays. Crops would fail, ecosystems collapse, and humanity might not survive. Though rare, gamma-ray bursts are reminders that our planet is not isolated, but part of a dangerous cosmic neighborhood. Even our own star, the Sun, carries dangers. Solar flares and coronal mass ejections hurl charged particles into space, sometimes striking Earth. In 1859, the Carrington event caused telegraph systems worldwide to spark and fail. If a storm of that magnitude struck today, it could cripple satellites, power grids, and communications. Planes would be grounded, hospitals darkened, economies frozen. Modern civilization, so dependent on electricity and networks, could unravel in weeks. Larger solar events are possible. The Sun is our life source, but it can also be our greatest vulnerability. Our shield is thin. Earth's atmosphere, the fragile veil that protects us, is only a few dozen kilometers thick. Beyond it lies a universe indifferent to our survival. One asteroid, one burst of cosmic radiation, one solar storm, any could undo centuries of progress. We may believe ourselves secure, but history shows otherwise. For the first time, humanity has tools to defend itself. We can track asteroids, study the Sun, and develop warning systems. We dream of colonies on Mars, space stations, and planetary defense. But we must also accept how small we remain in the face of cosmic forces. The dinosaurs had no warning, no defense. We may have telescopes and rockets, but we are still learning. The future threats remind us that survival requires vigilance. We cannot control the cosmos. At best, we can prepare, adapt, and hope that when the universe tests us, we are ready. The cosmos holds dangers, but perhaps the greatest threats are no longer out there. They are here, in our laboratories, in our weapons silos, in our technologies, and in our choices. For the first time in history, humanity's survival depends less on asteroids or supervolcanoes than on itself. We have become both the architects of progress and the authors of our own potential destruction. Though the Cold War has ended, nuclear weapons have not vanished. Thousands remain armed and ready. Treaties slow their spread, but mistrust and rivalry ensure their survival. Even today, the United States, Russia, China, India, Pakistan, and others maintain arsenals capable of erasing millions in moments. The danger is not only intentional war but accident. Systems can fail, leaders can miscalculate. A false alarm, as in 1983, could still trigger annihilation. In an age of cyber warfare, hacking into warning systems or command networks adds new risks. Humanity remains seconds from midnight. The Black Death and Spanish flu were natural diseases. But in the modern era, biotechnology holds the power to create far worse. Advances in genetics, engineering promise cures, new crops, and medical miracles. Yet the same tools could be misused to design pathogens, viruses resistant to treatment, bacteria engineered to spread more easily, or entirely novel diseases against which humanity has no defense. Accidents in laboratories could spark outbreaks. Deliberate use in warfare or terrorism could unleash pandemics far deadlier than COVID-19, or even the 1918 flu. The power to reprogram life itself is in our hands, and with it comes the shadow of extinction. Another frontier of risk lies in intelligence, not human, but artificial. As machines grow more capable, able to learn, adapt, and act without direct guidance, questions arise. Could an artificial intelligence designed to optimize decide that humanity itself is an obstacle? Could autonomous systems armed with weapons make lethal choices without accountability? AI may cure diseases, solve climate change, or open new horizons of knowledge. But if unleashed recklessly, it could destabilize economies, spread disinformation, or worse, seize control of systems critical to survival. The line between helper and threat may blur faster than we can manage. Even without asteroids or AI, the climate itself remains a human-made risk. Fossil fuel burning continues, forests fall, and oceans acidify. Scientists warn that tipping points could trigger self-reinforcing loops. Once started, these processes may be unstoppable, driving Earth into a hothouse state where agriculture collapses and billions face famine. Unlike sudden catastrophes, this would be a slow suffocation, but no less deadly. Modern life depends on delicate systems, electricity grids, internet networks, supply chains, global trade. These systems are efficient but fragile. A massive cyber attack, solar storm, or coordinated sabotage could collapse them. Cities would face shortages of food, water, and medicine within days. Chaos would follow, and survival would no longer be certain. Unlike past societies, ours is globalized. Collapse in one region spreads rapidly to others. What happens in a lab in one city, or a conflict in one strait, can ripple across continents. Our world is interconnected, and therefore vulnerable. But the future is not only shadow. Unlike the dinosaurs or the victims of Toba, humanity has foresight. We can see threats before they strike. We can track asteroids, regulate weapons, secure laboratories, and guide technologies like AI responsibly. We can choose cooperation over rivalry, resilience over fragility. The question is not whether threats exist. They always have, and always will. The question is whether we will act. Earth has nearly ended 5 times before. Each time, life rebuilt, reshaped, renewed. But never before has a species held so much power over its own destiny. Humanity is both the asteroid and the refuge, the volcano and the survivor. The future threats remind us that survival is not guaranteed. It must be chosen, protected, earned. If we fail, our story may join the fossil record of extinctions. If we succeed, we may endure not just on Earth, but beyond it, carrying life into the stars. The world has nearly ended before. It will be tested again. The next chapter, however, is ours to write. High above our heads, beyond the reach of weather and clouds, lies a shield invisible to the naked eye yet vital to life itself. This is the ozone layer, a thin blanket of gas in Earth's stratosphere that absorbs most of the sun's harmful ultraviolet UV radiation. Without it, the surface of our planet would be bombarded by rays that damage DNA, trigger cancers, blind eyes, and scorch crops. For billions of years, life evolved under this protective veil. Plants spread across land because ozone filtered the sun's deadly glare. Animals thrived because their cells were not constantly shredded by ultraviolet light. Even humans, who emerged much later, lived safely beneath its cover, never realizing how dependent we were on this delicate layer of molecules high above. But in the 20th century, unknowingly, humanity began to unravel its own shield. In the 1930s, scientists discovered a new class of chemicals called chlorofluorocarbons, CFCs. They seemed miraculous. Non-toxic, non-flammable, stable, and cheap, they could be used in refrigeration, air conditioning, aerosol sprays, and industrial cleaning. CFCs quickly spread into everyday life. They cooled our homes, preserved our food, sprayed our perfumes, and powered consumer industries. But stability, their greatest advantage, was also their curse. CFCs do not break down in the lower atmosphere. Instead, they drift upward, reaching the stratosphere, where they are torn apart by sunlight. When this happens, they release chlorine atoms, which catalyze reactions that destroy ozone molecules. One chlorine atom can break apart tens of thousands of ozone molecules before being neutralized. For decades, nobody realized what was happening. The atmosphere seemed too vast, too infinite for human activity to affect. But in reality, our invisible emissions were tearing holes in the very shield that made Earth habitable. In the 1970s, scientists began to suspect something was wrong. Researchers like Sherwood Rowland and Mario Molina calculated that CFCs could indeed reach the stratosphere and threaten ozone. Their warnings, published in 1974, were met with skepticism, even ridicule. Industry groups dismissed the findings, insisting that human activities could not possibly affect the sky. Then, in the mid-1980s, British scientists working in Antarctica noticed something shocking. Each spring, ozone levels above the continent plummeted. Not just slightly, but catastrophically. Entire chunks of the ozone layer seemed to vanish, creating what the world would soon call the ozone hole. Satellite data confirmed it, a massive seasonal depletion of ozone directly linked to CFCs. The protective veil was thinning, and the sun's ultraviolet radiation was pouring through the gap. The implications were terrifying. Without ozone, skin cancer rates would skyrocket. Cataracts would blind millions. Crops would fail as UV radiation scorched their leaves. Marine plankton, the base of ocean food chains, would collapse, threatening global fisheries. Livestock would die in fields, their hides burned, their eyes clouded. Scientists warned that if CFC production continued unchecked, the ozone layer could be destroyed within decades. Earth would become a planet where sunlight itself was deadly. It was one of those rare moments in history when humanity realized it was standing on the edge of a man-made apocalypse. Imagine being in Antarctica in the mid-1980s. A scientist rises early, instruments whirring in the freezing dawn. The machine shows ozone concentrations plunging lower than ever before. Confusion turns to dread. Letters are written, reports filed. The news spreads. Our shield is failing. In those days, many ordinary people didn't understand the science, but they felt the fear. Newspaper headlines warned of holes in the sky. Parents worried about their children playing outside. Farmers asked what it meant for crops. Pilots flying high-altitude routes wondered about their exposure. For the first time, the atmosphere, something taken for granted, seemed fragile. Governments, usually slow to act, recognized the urgency. Unlike climate change today, the ozone crisis had a direct villain, CFCs, and a clear solution: ban them. The world came together in a rare act of unity. In 1987, nations signed the Montreal Protocol agreeing to phase out ozone-depleting chemicals. It became one of the most successful environmental treaties in history. Industries adapted, developing safer alternatives. Production of CFCs plummeted. But healing would take time. Ozone is destroyed far faster than it regenerates. Even with emissions stopped, recovery would span decades. Still, humanity had acted just in time. By the early 21st century, satellites confirmed that the ozone layer was slowly healing. The hole still appears seasonally, but it is shrinking. Scientists project that by the middle of the century, much of the damage will be repaired. If not for the Montreal Protocol, Earth today might already be unrecognizable. Skin cancers would be epidemic. Agricultural yields would collapse. Climate would be altered, since CFCs are also powerful greenhouse gases. Humanity had brushed against the edge of disaster and stepped back. The ozone crisis proved that global cooperation is possible. It showed that science can warn us in time and that policy, industry and society can respond. It is in many ways a success story, but also a warning. Because while we acted for the ozone, we hesitate on climate, and the stakes now are far higher. The ozone hole was a glimpse of how fragile our atmosphere is, how much we depend on invisible balances we rarely notice. It was one of the times the world nearly ended, and one of the few when humanity chose survival. The discovery of the ozone hole in the 1980s shocked the world. For once, the crisis was undeniable. The images from satellites were stark. A yawning blue void opening above Antarctica, sunlight streaming through, exposing the Earth to invisible danger. The message was clear. Humanity had tampered with the sky itself. In a world divided by Cold War politics, nuclear arsenals, and ideological clashes, cooperation seemed impossible. Yet the ozone crisis did something extraordinary. It united humanity against a common threat. In 1987, representatives from dozens of nations gathered in Montreal, Canada. Scientists presented their evidence. Industry lobbied to protect profits. Activists demanded change. Negotiations were tense, but the urgency was undeniable. Out of that meeting came the Montreal Protocol on substances that deplete the ozone layer. It was a landmark treaty. For the first time in history, nations agreed not just to regulate pollution, but to eliminate entire classes of chemicals from the global economy. CFCs, halons, and other ozone-depleting substances were scheduled for phase-out. The treaty included mechanisms for adjustment as science advanced, ensuring it could grow stronger with time. Over the following decades, nearly every nation on Earth signed and ratified it. Alternatives were developed. Refrigerators, air conditioners, and aerosol sprays were redesigned. Industries resisted at first, but innovation brought profits even in compliance. By the 21st century, CFC production had plummeted by more than 99%. The Montreal Protocol is still hailed as the most successful environmental treaty in history. The ozone story proved something that many had doubted, that humanity could act collectively in time to avert disaster. Scientists warned, policymakers listened, industries adapted, and society accepted change. The crisis was large, but the solution was simple enough: eliminate the source. This cooperation set a precedent for global action on environmental issues. It inspired climate negotiations, biodiversity treaties, and new environmental frameworks. The ozone layer became not only a shield but a symbol, proof that the world could work together when survival demanded it. But what if things had gone differently? Imagine an alternate history where industries had resisted more fiercely, governments had delayed, and the Montreal Protocol had collapsed. In this world, CFC production would have continued unchecked. By the early 21st century, ozone depletion would have spread far beyond Antarctica. Entire regions would face year-round ozone holes. Sunlight itself would become dangerous. Skin cancer rates would have exploded. Scientists estimate that without the protocol, millions of additional cases of cancer and cataracts would have occurred every year. Agricultural systems would falter as crops exposed to harsh UV failed in fields. Marine ecosystems, especially plankton, the foundation of the ocean food chain, would collapse. Fisheries that feed billions would wither. The economic toll would have been incalculable. Outdoor work would become deadly in many regions. Tourism would vanish. Healthcare systems would collapse under the weight of cancer cases. Entire societies would retreat indoors, dependent on technology to shield them from their own skies. It would have been an apocalypse not in fire or ice, but in light. Sunlight transformed from life-giving to lethal. Instead, we live in a different story. The ozone hole, though still present seasonally, is healing. Each year, satellites measure gradual recovery. By mid-century, scientists believe the ozone layer will be largely restored. Humanity acted at the brink and stepped back. The ozone crisis is often forgotten today, overshadowed by climate change and other challenges. But it remains one of our most important victories. It proved that humans are not only destroyers, but also stewards. It showed that foresight is possible, that cooperation can triumph, that apocalypse can be averted. The story of the ozone layer holds powerful lessons. It teaches us that invisible threats are no less deadly. It shows that waiting for undeniable proof is dangerous, but that decisive action can work. Most of all, it reminds us that global survival requires global unity. As we face climate change, pandemics, and technological risks, the Montreal Protocol stands as a blueprint. The world nearly ended in ultraviolet light, but it didn't. Because once, just once, humanity chose wisely. Beneath our feet, Earth is alive. Its surface seems solid, but it floats on a sea of molten rock and shifting plates. Above us, the atmosphere seems calm, but it seethes with energy, warmed by the sun and driven by oceans. These forces, tectonic and atmospheric, are reminders that we do not rule this planet. We live at its mercy. Throughout history, natural disasters have erased cities and rewritten maps. Earthquakes have toppled empires, storms have drowned nations, and tsunamis have erased coastlines. And yet, what we have seen in modern times may be only a fraction of what this restless planet can unleash. On December 26, 2004, the world witnessed one of the deadliest natural disasters in history. Off the coast of Sumatra, a massive earthquake ruptured the seafloor. The sudden shift displaced billions of tons of water, sending a wall of waves racing across the Indian Ocean. Within hours, entire coastlines were obliterated. Beaches in Thailand were swept away. Villages in Sri Lanka vanished. Somalia, thousands of miles away, felt the surge. In all, more than 230,000 people died in a single day. Families were torn apart, cities reduced to ruins, and the ocean itself became a weapon. Yet even this catastrophe was modest compared to what Earth has unleashed in the past. Ancient records describe mega tsunamis hundreds of meters high, triggered by volcanic collapses or asteroid impacts. Scientists believe that if the volcanic island of Cumbre Vieja in the Canary Islands were to partially collapse, it could send a wave across the Atlantic, devastating coasts from Morocco to New York. Humanity builds cities on coastlines, confident in seawalls and warnings. But against the true force of the ocean, there is little defense. On March 11, 2011, Japan was shaken by a magnitude 9.1 earthquake, one of the strongest ever recorded. Buildings swayed like trees, roads split open. Then came the tsunami, towering waves that surged inland, sweeping cars, ships and homes as if they were toys. More than 15,000 people were killed, and the Fukushima nuclear disaster unfolded in its wake. The quake was massive, but geologists warn of even greater ones waiting. Along the Cascadia subduction zone off the Pacific Northwest, plates are locked, building strain. When it ruptures, it could unleash a quake as strong as 9.0, followed by a tsunami that would drown coastal cities from Seattle to Vancouver. Experts call it not a question of if, but when. The San Andreas Fault in California too slumbers uneasily. Smaller quakes remind residents of its presence, but history suggests it is capable of a massive rupture. A true big one could devastate Los Angeles and San Francisco, crippling the world's fifth largest economy in hours. Humanity builds skyscrapers, dams, and power plants. But the Earth can shatter them in seconds. The atmosphere too holds apocalyptic power. Hurricanes, typhoons, and cyclones form when warm oceans feed energy into spiraling winds. Most fade or strike with limited fury, but some grow monstrous. In 2005, Hurricane Katrina drowned New Orleans, killing more than 1,800 and displacing millions. In 2013, Typhoon Haiyan struck the Philippines with winds of over 190 miles per hour, leveling cities and killing thousands. These storms were devastating, yet they may not represent the upper limits. Climate scientists warn that warming seas are creating conditions for superstorms beyond anything recorded. Imagine a hurricane sustained by hotter oceans, with winds over 250 miles per hour, storm surges tens of feet high, and rainfall measured in meters. A storm like that could erase modern coastal cities, not just damage them, but wipe them from the map. Ancient societies knew these dangers. Legends of great floods, sinking cities, and wrathful gods are often echoes of real catastrophes. The Minoan civilization may have been shattered by the eruption of Thera and the tsunami that followed. Entire cultures have risen and fallen under the weight of earthquakes and storms. Modern society likes to believe it is different, shielded by technology. But our cities are bigger, our populations denser, our infrastructures more fragile than ever. A superstorm today would not destroy a village, it would drown a metropolis. A megaquake would not topple temples, it would collapse skyscrapers and nuclear plants. The stakes are higher than ever. Unlike asteroids, we cannot deflect storms or earthquakes. We can predict, prepare, and rebuild, but we cannot prevent. And as the climate warms, superstorms grow stronger, while tectonic pressure builds beneath our feet. The Earth has ended worlds before, the worlds of civilizations now reduced to ruins. It may do so again. Along North America's Pacific Northwest lies a hidden monster, the Cascadia Subduction Zone. Stretching from northern California to British Columbia, this 600-mile fault marks the boundary where the Juan Fuca Plate grinds beneath the North American plate. For centuries, it has been silent. Towns and cities have grown above it, Seattle, Portland, Vancouver, unaware of the tension beneath their streets. But geologists know the truth. Sediment layers, drowned forests, and Japanese tsunami records reveal its past. On January 26, 1700, Cascadia broke with a magnitude 9.0 quake. The ground shook for minutes, coastlines dropped, and a tsunami raced across the Pacific, slamming into Japan hours later. 3 centuries have passed. Pressure has built again. When Cascadia ruptures next, and it will, shaking will topple skyscrapers, bridges, and freeways. Coastal towns will vanish under walls of water. Millions will be displaced. The Pacific Northwest, one of the world's most prosperous regions, could be reduced to rubble in a single day. Across the ocean, another threat looms. The volcanic island of La Palma in the Canary Islands. Its western flank is unstable. If a future eruption triggers a collapse, scientists warn that massive chunks of rock could plunge into the Atlantic Ocean, displacing unimaginable volumes of water. The result? A mega tsunami, waves hundreds of feet high racing across the ocean. Within hours, the coasts of Africa and Europe would be inundated. Within 10, the waves could reach the Americas. Cities like Casablanca, Lisbon, Rio de Janeiro, Miami, and New York could face devastation on scales rivaling nuclear strikes. Millions could die, not from fire or war, but from the sea rising in wrath. Skeptics debate the likelihood of such a collapse. But the physics are undeniable. Earth's crust is unstable. Oceans are vast and human civilizations cluster along shorelines. We live at the water's edge, and that edge is never safe. If tectonics and tsunamis represent Earth's power from below, storms reveal its fury from above. Hurricanes already devastate coastal nations, but climate change may be forging storms beyond imagination. Warmer seas feed cyclones with energy. Higher temperatures load the atmosphere with moisture. Rising seas magnify storm surges. Together they create the ingredients for superstorms. Hurricanes larger, stronger, and more persistent than anything in recorded history. Scientists model storms with winds over 250 miles per hour, storm surges swallowing entire coastal plains, and rainfalls flooding inland for hundreds of miles. Such a storm could erase Miami, devastate Bangladesh, or leave the Philippines uninhabitable. Unlike earthquakes, these storms will not be once-in-a-century surprises. They will become more frequent as the climate warms. The storms of tomorrow will not only destroy cities, they may redraw maps. The greatest danger is not the event itself, but our vulnerability. Ancient societies faced disasters, but their populations were smaller, their technologies simpler. A flood might drown a village, but life elsewhere continued. Today, billions live in coastal megacities: Tokyo, New York, Mumbai, Jakarta, Lagos. A megaquake or superstorm striking one of these hubs would not only kill millions but also shatter global trade, finance, and supply chains. The effects would ripple worldwide. Our world is interconnected. One rupture in Cascadia, one collapse in La Palma, one superstorm in the Gulf of Mexico. Any could trigger global recession, famine, political chaos. Modern civilization rests on fragile foundations. We build seawalls, early warning systems, earthquake-resistant skyscrapers. These save lives, but they are stopgaps, not shields. When Earth truly unleashes its force, there is little we can do. Disaster planners know this. They call Cascadia's coming quake the big one. They model hurricane scenarios that erase cities. They warn of tsunamis that would make Fukushima seem small. Yet most of the world lives unprepared, distracted by everyday concerns, unaware of how thin the line of stability truly is. The 2004 tsunami, the 2011 Japan quake, Hurricane Katrina, Typhoon Haiyan. These were previews, not finales. History teaches us that disasters will come again, larger, deadlier, and at times we least expect. When they do, will humanity endure? Likely yes, but societies may crumble, cities may vanish, millions may die. The world will not end, but worlds, cultures, nations, ways of life could. The Earth itself is a threat, restless and indifferent. We forget this because our lives are brief compared to its cycles, but the ground shakes, the seas rise, the storms gather, and one day again we will be reminded who truly holds power on this planet. If fire, storms and asteroids remind us of Earth's raw power, then pandemics remind us of our fragility. Unlike earthquakes or volcanoes, pandemics do not shatter buildings. They shatter people, families and societies. They creep silently through crowds, spread on the air we breathe, and turn our greatest strength, our interconnectedness, into our greatest weakness. In the 21st century, humanity believed it had triumphed over disease. Antibiotics had tamed infections. Vaccines had defeated smallpox and crippled polio. Medical science seemed unassailable. Yet, in 2020, the world was reminded of an ancient truth. Microbes have always been our most relentless adversaries. Long before COVID-19, scientists had warned that the modern world was ripe for pandemics. Air travel meant that a virus could circle the globe in 24 hours. Deforestation brought humans into contact with animal reservoirs of disease. Industrial farming packed livestock tightly, creating breeding grounds for mutations. Wet markets, war zones, refugee camps, all were crucibles for contagion. We had been warned by outbreaks. SARS, 2003, a coronavirus that spread across Asia. H1N1, 2009, a flu pandemic that infected millions. Ebola, 2014 to 2016, which ravaged West Africa with terrifying lethality. Each outbreak flared, frightened, and faded. The world returned to normal, unprepared for the one that would not fade. In late 2019, reports surfaced of unusual pneumonia cases in Wuhan, China. At first, they seemed isolated, but by January 2020, the virus had spread across borders. Within months, it was everywhere. Airports, trains, and markets became conduits. Entire nations shut down. Streets emptied, economies froze, hospitals overflowed. COVID-19 revealed how quickly the modern world could grind to a halt. Masks, lockdowns, and vaccines became household words. Millions died. Many more were scarred physically and psychologically. Families were separated by quarantines. Funerals were held on video calls. Children grew up behind screens. For the first time in living memory, the entire planet experienced a shared catastrophe. The numbers tell one story. Over 6 million dead worldwide by official counts, likely far more in reality. But the deeper toll was in the fabric of life. In Italy, military trucks carried coffins because morgues were full. In India, rivers filled with makeshift funeral pyres. In the United States, refrigerated trucks parked outside hospitals storing the dead. In Brazil, graves were dug so quickly that families barely said goodbye. Healthcare workers collapsed from exhaustion. Teachers struggled to adapt classrooms. Millions lost jobs. Millions more sank into poverty. It was not just a disease, it was a stress test for civilization, and in many ways, we failed. Pandemics reveal cracks. Supply chains broke when factories shut down. Supermarket shelves emptied. Flights were cancelled, borders sealed. Even wealthy nations discovered they lacked masks, ventilators, and basic protective equipment. The illusion of stability dissolved. Suddenly, people realized how dependent they were on fragile, globalized systems. A virus invisible to the naked eye had shaken the pillars of trade, politics, and society. COVID-19 was not the first plague to test humanity. It was part of a long lineage stretching back to the Black Death of the 14th century and the Spanish flu of 1918. Each time, societies were reshaped. Each time, death forced change. The Black Death toppled feudalism, empowering peasants. The Spanish flu spurred new investments in public health. COVID-19 too will leave its mark. Remote work, digital economies, vaccine, technology, and renewed awareness of biosecurity are all legacies of the pandemic. But the lesson remains the same. We are never beyond the reach of microbes. Scientists agree that COVID-19 was not the last. It may not even be the worst. The conditions that birthed it, global travel, deforestation, intensive farming, are still with us. Viruses still circulate in bats, birds, and pigs, waiting for a mutation that lets them leap to humans. The question is not if another pandemic comes, but when, and whether we will be ready. Unlike an asteroid strike, pandemics unfold in waves. They kill not in minutes, but in weeks and months. They grind down societies, wear away trust, exhaust economies. They rarely kill everyone, but they change everything. COVID-19 reminded us that apocalypse need not be sudden. It can be slow, invisible, and intimate, arriving not with fire but with a cough. Picture the spring of 2020. The streets of New York, normally roaring with traffic, fell silent. In Delhi, smog cleared for the first time in decades, revealing distant mountains. In Rome, priests live-streamed mass to empty pews. Airports stood ghostly, planes grounded. The world itself seemed to hold its breath. It was as if humanity had stepped out of history into a strange limbo. A reminder that our civilizations, vast and mighty, can be silenced by something smaller than a grain of dust. Pandemics humble us. They remind us that despite our skyscrapers, satellites, and smartphones, we are still animals bound by biology. We breathe, we bleed, we sicken, we die. We live in groups, and in those groups microbes thrive. The age of pandemics is not over, it is only beginning. Natural pandemics are terrifying enough. But in the 21st century, a darker possibility has emerged, that humanity might one day create, accidentally or deliberately, a disease even worse than nature ever could. The same technologies that allow us to cure illnesses and develop vaccines also give us the ability to re-engineer microbes. And in the wrong hands, that power becomes a weapon. The Black Death spread from fleas. The Spanish flu emerged from crowded camps and trenches. COVID-19 likely came from animal spillover. But tomorrow's pandemic could come from a laboratory bench. Modern biotechnology is a double-edged sword. Tools like CRISPR gene editing and synthetic biology allow scientists to rewrite DNA with precision unimaginable a generation ago. Researchers can revive extinct viruses, enhance pathogens to study them, or design microbes for industrial uses. The intention may be noble, to understand threats before they strike, to build defences, to treat diseases. But the same knowledge can be turned toward harm. A virus made more transmissible, a bacterium engineered to resist all antibiotics, a pathogen crafted with a long incubation period, spreading silently before symptoms appear. This is the dual-use dilemma, the line between science for good and science for catastrophe is dangerously thin. Humans have long used disease as a weapon. In the 14th century, besieging armies catapulted plague-ridden corpses into cities. In colonial wars, blankets infected with smallpox were given to indigenous peoples. In the 20th century, governments experimented with biological warfare on industrial scales. The Soviet Union maintained massive programs, weaponizing anthrax, smallpox, and plague. The United States explored bioweapons before renouncing them under international treaties. Yet even treaties cannot erase knowledge. Once a weapon is conceived, it lingers in the minds of scientists and in classified documents, waiting to resurface. Imagine a virus engineered for maximum devastation. It spreads as easily as measles through the air. Its incubation period is long, so carriers travel the globe before symptoms appear. It evades immune responses, mutating faster than vaccines can be developed. Its lethality rivals Ebola, killing most of those infected. Such a pathogen could sweep across the world in weeks. Hospitals would collapse within days. Governments would lock borders, but by then it would be too late. Food supply chains would fail as workers fell ill. Societies would fracture under fear and mistrust. Unlike COVID-19, which killed millions but left civilization intact, this engineered plague could push humanity toward true extinction. Could we defend ourselves? Perhaps, but our defenses are limited. Vaccines take time to develop. Antivirals are scarce. Global coordination is often slow. And engineered pathogens might be designed to resist our treatments entirely. Even if survivors remained, the collapse of global society could erase centuries of progress. Power grids would fail, cities empty, knowledge lost. The survivors might live scattered in isolated pockets, as fragile as early humans after Toba's eruption. Civilization could fall, not by asteroid or fire, but by microbes we ourselves unleashed. The threat is not only malice. Laboratories studying dangerous pathogens risk accidents. History records leaks of smallpox, anthrax and SARS from supposedly secure facilities. In a world where dozens of labs study high-risk viruses, the chance of a mishap is never zero. A single error, a misplaced vial, a faulty seal, a breach in protocol could release a pathogen into the world. From there, nature would take over. The age of pandemics forces humanity to confront its own ethics. Should we study dangerous pathogens to prepare defenses, knowing that the research itself creates risks? Should we allow technologies that can build viruses from digital blueprints to circulate freely, or restrict them at the cost of slowing progress? The debate is unresolved, but one fact is clear. The power to shape life now rests in human hands, and with that power comes the possibility of shaping death. In myths, apocalypse rides with horsemen: war, famine, pestilence, and death. In our age, pestilence is no longer only a natural horseman. It is one we may summon ourselves, knowingly or unknowingly. Pandemics have already reshaped history. The Black Death changed Europe's economy. The Spanish flu scarred the 20th century. COVID-19 redefined the 21st. But an engineered pandemic could go further, not changing history, but ending it. The age of pandemics is not over, it is accelerating. And whether it destroys us or teaches us resilience depends on how wisely we wield our knowledge. If we act with foresight, we may build defenses so strong that no microbe can defeat us. If we act recklessly, we may create the very plague that ends us. The choice, as always, is ours. Humanity has always lived with immediate threats: earthquakes, plagues, wars, and storms. But when we look farther, beyond centuries and millennia, we see that the greatest threat of all is time itself. The universe does not stand still. Stars burn, galaxies collide, and entropy marches forward. No matter how clever or resilient we are, the cosmos has an endgame, and at the centre of that endgame is our sun. The sun is not eternal. It is a star, and like all stars, it has a life cycle. Born 4.6 billion years ago, it is already middle-aged. For now it burns steadily, fusing hydrogen into helium at its core, radiating the light and warmth that sustain life. But even now, changes are underway. Astronomers estimate that in about 1 billion years, the sun's energy output will increase by roughly 10%. It may not sound like much, but it will be enough to disrupt the delicate balance of Earth's climate. Oceans will begin to evaporate. Carbon dioxide levels will plummet as weathering processes accelerate, making photosynthesis impossible. Plants will die, followed by animals. Long before the sun expands into a red giant, Earth will already have become a barren, lifeless rock. 5 billion years from now, the sun will exhaust its hydrogen and begin fusing helium. Its core will contract, and its outer layers will expand. The sun will swell into a red giant, growing so vast that it may engulf Mercury and Venus, and perhaps even Earth. Even if Earth escapes direct engulfment, it will not escape destruction. The sun's expansion will boil away the atmosphere, vaporize oceans, and bake the crust. For billions of years, Earth has nurtured life. In the red giant phase, it will be sterilized. The world we know will end, not in fire from within or impact from above, but in the slow, inevitable evolution of our star. After its red giant phase, the sun will shed its outer layers into space, creating a glowing shell of gas called a planetary nebula. At its heart will remain a dense ember, a white dwarf, no larger than Earth, but with half the sun's mass. This white dwarf will no longer produce energy. It will slowly cool over trillions of years, fading into darkness. The solar system will be left cold and dead, its planets barren or gone, its light extinguished. The fate of the sun is only one story in a larger cosmic narrative. Across the universe, stars are born and die in cycles of creation and destruction. Galaxies collide, black holes devour matter, and supernovae scatter heavy elements into space. The cosmos is not static. It is a vast machine of change, and eventually its cycles will erase everything we know. For Earth, the timeline is certain. Within 1 billion years, it will no longer support life. Within 5 billion, it will be destroyed. The only uncertainty is whether humanity, or our descendants, biological or artificial, will still be here to witness it. Civilizations measure time in centuries, religions in millennia, species in millions of years. But stars measure time in billions. Against such scales, our achievements, our empires, even our survival seem fleeting. The pyramids, the Great Wall, the Internet, all will vanish long before the sun begins its final phase. This perspective is humbling. We may fear asteroids or plagues, but they are brief trials. The ultimate apocalypse is written in the physics of the stars. The question, then, is not whether Earth will end. It will. The question is whether humanity, or its descendants, will find a way to leave. To survive the sun's death, we must eventually become a spacefaring species. Colonies on Mars may buy time, but even Mars will burn. We will need to leap across stars, build habitats in space, harness energies far beyond our current reach. It is the greatest challenge imaginable, but it is also the only way to endure. For now, the apocalypse is distant. We have time, more time than we need to solve today's crises. But the sun's fate is a reminder. Survival is not guaranteed. The world has ended before, and it will end again. To continue, we must look beyond Earth, beyond centuries, beyond even history itself. The long future belongs not to those who wait, but to those who prepare. The death of the sun, 5 billion years away, is only the beginning of a far grander story. The story of the universe itself. Earth's fate is tragic, but the cosmos has an even darker destiny. When we gaze into the night sky, we see galaxies sparkling, stars being born, nebulae glowing in colour. It feels eternal, but the universe is not eternal in its current form. It too is on a path toward an ending. At the heart of cosmic doom is a simple principle: entropy. In physics, entropy is the measure of disorder. Every star that burns, every planet that spins, every life that moves increases entropy. Energy flows from order to chaos. Over time, usable energy becomes scarce. The universe trends toward equilibrium, where no more work can be done. This is called the heat death of the universe. It is not a fiery explosion, but the ultimate silence. A universe gone cold, dark, and still. Trillions of years from now, stars will exhaust their fuel. Galaxies will stop forming. White dwarfs will cool into black dwarfs, faint cinders in the void. Black holes will swallow stars and planets, then slowly evaporate themselves through Hawking radiation. Imagine a sky without stars, only darkness, punctuated by the faint whisper of matter fading away. Time stretches on, but nothing changes. There is no energy gradient, no heat to drive life, no stars to light the sky. This is not an apocalypse in the sense we know it. It is a fading, a slow extinguishing of everything. The universe will not explode. It will not collapse. It will simply end in stillness. Some cosmologists propose a different fate. If the mysterious force known as dark energy continues to accelerate the expansion of the universe, it may not only push galaxies apart, but eventually tear space-time itself. In this scenario, billions of years from now, galaxies drift beyond one another's reach. Stars once clustered in constellations vanish from view. The night sky grows emptier. Eventually, gravity itself cannot hold galaxies together. Solar systems unravel, planets drift away, and even atoms are torn apart. The universe does not fade to silence. It rips apart in violence. The end comes not with a whimper, but with everything, everywhere, shredding into nothingness. Another possibility is that black holes will dominate the universe's future. Stars die, galaxies scatter, but black holes remain, devouring, colliding, and growing. In the far, far future, only black holes may exist, ruling an empty cosmos. But even they are not eternal. According to Stephen Hawking's predictions, black holes slowly evaporate, releasing radiation. Over unimaginable timescales, 100 billion years or more, they too will fade. The universe will be left with nothing but stray particles drifting through infinite dark. At these scales, even time itself seems meaningless. What does year mean when stars no longer shine? What does future mean when no events remain? The ultimate apocalypse may not be fire or flood, but the collapse of meaning itself. For civilizations, if any still exist, such endings would be incomprehensible. There would be no energy to harness, no heat to capture, no light to see. Thought, memory, and life itself would vanish. We may never see these endings. Long before, our species may vanish, or transform, or escape to other universes if such things are possible. Yet the knowledge of these fates humbles us. It reminds us that even the universe is mortal. We often think of apocalypse as human, plagues, wars, asteroids. But the cosmos itself writes a larger apocalypse, one that no ingenuity can prevent. At best, we might delay our extinction. We cannot outlive the death of the universe. Imagine the last star flickering out. Imagine galaxies scattered so far that no light connects them. Imagine black holes evaporating into emptiness. Then imagine the stillness that follows. No light, no warmth, no sound. A cosmos of pure darkness, infinite and eternal. That is the heat death. The end not only of worlds, but of all time, all history. And yet, we live now in a young universe still ablaze with stars. We have billions of years before the sun dies, trillions before the cosmos fades. The end is written, but the middle remains unwritten. Our choices today, our survival tomorrow, our journeys into space, these will shape how long we endure before the final silence. The cosmic endings remind us that everything ends, but they also remind us that, for now, we still have time. Human history is filled with surprises. When the Black Death struck in the 14th century, no one saw it coming. When an asteroid ended the dinosaurs, they had no way to prepare. Even modern disasters, the 2004 tsunami, the 2020 COVID-19 pandemic, blindsided governments and scientists despite warnings. The truth is uncomfortable. The greatest dangers may not be the ones we anticipate, but the ones we cannot imagine. Humanity plans for earthquakes, for hurricanes, for nuclear war. But what about the threats that lurk outside our models? What about the catastrophes we don't yet have names for? We know about asteroids. We track thousands of them. But what about rogue planets, massive worlds that drift through the galaxy after being ejected from their star systems? Astronomers believe billions exist. They travel silently, dark and cold, invisible against the night. If one passed near our solar system, it could destabilize planetary orbits. A close encounter could hurl Earth into a new orbit. Too close to the sun, boiling oceans, or too far, freezing solid. A direct collision, though unlikely, would erase Earth in an instant. And rogue planets are only one category of cosmic ghost. Black holes too wander the galaxy. A small, undetected one drifting near Earth could distort gravity, disrupt satellites, or even pull our planet apart. We cannot prepare for what we cannot see. Pandemics remind us that life is unpredictable. But what if a pathogen unlike anything we know emerges? Viruses and bacteria evolve constantly. Deep in rainforests, frozen in permafrost, or lurking in caves, countless microbes wait. Some may never harm us. Others may one day leap across species barriers with devastating consequences. Even more chilling, synthetic biology could create life forms so alien that our immune systems fail entirely. We prepare for flu, for coronaviruses, for known threats. But what if the next microbe doesn't fit any category? History tells us that biology always finds a way. Humanity's blind spot is believing we've seen every card the deck holds. We have not. Technology is our greatest strength, and our most unpredictable weakness. The internet was designed for communication. It also enabled cyber warfare. Nuclear fission was discovered for energy. It produced weapons of mass destruction. Artificial intelligence promises medical breakthroughs, but also risks losing control. The danger is not only malicious intent, but emergent consequences. Imagine self-replicating nanobots designed for medicine, accidentally consuming ecosystems. Imagine AI systems misaligned with human values, making irreversible decisions. Imagine genetic engineering intended to cure, instead triggering ecological collapse. We cannot foresee every outcome. The unknown lies in the gap between invention and understanding. Modern civilization depends on interconnected systems, electricity grids, satellites, supply chains. They are efficient but brittle. A single failure can ripple into collapse. What if a cascading blackout triggers a global financial crash? What if a software bug in critical infrastructure spreads worldwide before anyone notices? What if satellites collide, creating a chain reaction of debris that shatters space travel for centuries, the Kessler syndrome. These are not science fiction. They are plausible, but outside the imagination of most people. Our comfort blinds us to how fragile the systems beneath our lives truly are. Not every ending needs to come from physics or biology. Sometimes fear alone is enough. Financial markets can collapse in hours if trust evaporates. Governments can fall if panic spreads. Societies can destroy themselves if misinformation convinces millions that collapse is inevitable. Apocalypse can be psychological. In a hyper-connected world, rumours move faster than truth. Fear spreads like a virus, and in some cases it may be the most dangerous contagion of all. We cannot predict every threat, but we can prepare for the reality that the unknown always exists. Resilience, flexible systems, adaptable societies, strong science is our best defence. The world may not end tomorrow or in 1,000 years, but something will test us, perhaps something we have never considered. The unknown is not just a danger, it is a certainty. For centuries humans have wondered if we are alone in the universe. With billions of stars and trillions of planets, it seems unlikely that Earth is the only world with life. Yet the Fermi paradox lingers. If intelligent civilizations exist, where are they? Some scientists suggest they are simply too far away. Others propose they may not want to be seen. But a darker possibility exists. What if civilizations that rise too high inevitably fall, destroyed by war, by disease, or by technologies they cannot control? Perhaps silence is not absence, but warning. And then comes the unsettling thought. What if we are noticed? Contact with extraterrestrials might be humanity's greatest achievement, or its end. Advanced civilizations could see us as competitors, resources, or experiments. A single probe, a single message, could destabilize our world, not through lasers or warships, but through the collapse of our beliefs. The alien threat is not only physical, it could be psychological. The mere knowledge that we are not alone could shatter religions, philosophies, and societies built on human uniqueness. Some thinkers suggest that reality itself may be a simulation, a cosmic program running on unknown machinery. If so, then our universe could end not with a bang or a whimper, but with a shutdown. The theory may sound fantastical, but it cannot be disproven. If our world is simulated, then glitches, resets, or intentional deletions could occur. From our perspective, it would appear as sudden, inexplicable catastrophe, reality itself unravelling. What if déjà vu, anomalies, or cosmic coincidences are hints of underlying code? What if our simulation has an expiration date? The end could come not through volcanoes or viruses, but through a decision in another reality to turn us off. Even without aliens or simulations, there may be forces we simply do not understand yet. Physics itself is incomplete. Dark matter, dark energy, quantum mysteries. These are clues to vast realities beyond our comprehension. What if dark matter interacts in ways we do not yet detect, one day triggering a cascade that destabilizes stars? What if a new law of physics reveals itself, one that makes our universe unstable? We live in a cosmos we barely grasp. Ignorance itself may be a threat. Our ancestors never imagined nuclear bombs or engineered viruses. Today, we cannot imagine the dangers our descendants may face. Each generation sees only part of the board. The rest lies hidden, waiting. The unknown is not a category. It is the essence of existence. Life thrives by adapting to surprises. Extinction comes when surprises overwhelm. What ends the world may not be what we fear. It may not be an asteroid, or a plague, or even the death of the sun. It may be something so alien, so unthinkable, that we cannot prepare for it. And perhaps that is the greatest truth. Apocalypse is always a surprise.